Hello there, and welcome. Tonight I want to take you somewhere special, somewhere that exists both infinitely far away and somehow right here with us in this very moment. As you settle in, perhaps adjusting your pillow, finding that perfect position where your body can finally release the weight of the day, I want you to know that you found exactly the right place to be. The universe has a way of bringing us together at just the right moments, and tonight, whether you're listening from a bustling city where the lights never quite dim, or from a quiet countryside where the stars peek through your window, or perhaps from somewhere in between, we're all gathering here under the same vast cosmic canopy, ready to explore one of the most beautiful questions that modern physics has dared to whisper into the darkness. Before we drift deeper into this cosmic mystery together, I'm curious about you, about where you're joining us from tonight. What time is it where you are? Is it that perfect late evening hour when the world finally quiets down? Or perhaps you're stealing a moment in the afternoon for a peaceful rest? Or maybe it's those precious pre-dawn hours when the boundary between dreams and waking becomes beautifully blurred. Wherever and whenever you are, I'd love to know. Leave a gentle comment below, share your corner of the world with our little community of cosmic dreamers. And if you find yourself returning to these peaceful explorations night after night, consider subscribing, becoming part of our constellation of listeners who gather here regularly to ponder the infinite while drifting towards sleep. Hit that like button if this journey resonates with you, not because I'm asking you to, but because it helps other restless minds find their way here too, to this quiet space we're creating together beneath the stars. Tonight's question begins so simply, yet it opens doorways to possibilities that stretch our imagination to its gentlest limits. What if black holes, those mysterious dark spheres scattered throughout our universe like silent sentinels, were not endings but beginnings? What if each one was not a cosmic grave but a cosmic cradle, nurturing baby universes in dimensions we cannot see, cannot touch, but might somehow sense in our quietest moments of wonder? It's a question that at first might sound like pure fantasy, something from the pages of science fiction rather than the equations of theoretical physics. But the more we sit with this idea, the more we let it settle into our consciousness, like starlight settling on still water, the more it begins to reveal itself as not just possible, but perhaps even probable, perhaps even beautiful in its implications for what reality truly is. You see, we live in an age where the impossible has a curious habit of becoming possible, where the universe reveals itself to be far stranger, far more wonderful than our ancestors could have imagined when they first looked up at these same stars that watch over us tonight. Just a century ago, the idea that space itself could bend and curve seemed absurd. The notion that time could slow down or speed up depending on how fast you moved or how close you stood to a massive object would have been dismissed as fantasy. Yet here we are, carrying devices in our pockets that must account for these very effects to tell us where we are on Earth's surface. The GPS satellites orbiting above us right now, perhaps passing over your home as we speak, must constantly adjust their clocks because time passes differently for them up there than it does for us down here. Einstein's impossible ideas have become so real that we depend on them for something as mundane as finding the nearest coffee shop. And so tonight, as we explore this question of black holes as doorways to baby universes, we're not venturing into pure speculation, but rather into that beautiful borderland where current science meets future possibility, where what we know dissolves gently into what we might discover, where equations written on blackboards in quiet university offices might be describing realities more vast and various than we've yet dared to believe. This is not a journey that requires you to abandon your skepticism or your scientific grounding. Quite the opposite. We're going to build our wondering on the solid foundation of what astronomers and physicists have actually observed, what the data actually suggests, what the mathematics actually allows. But we're also going to let ourselves dream a little, to follow those observations and equations to their most profound possible conclusions. The universe has always been generous with its mysteries, hasn't it? Every time we think we've figured something out, every time we believe we've drawn the final map of reality, the cosmos gently laughs and shows us a new room we hadn't noticed, a new door we hadn't seen. For thousands of years we thought the stars were fixed, eternal, unchanging. Then we discovered they were born, lived and died in cycles lasting millions or billions of years. We thought atoms were the smallest things that could exist, indivisible and fundamental. Then we found they were made of smaller particles, and those particles of even smaller ones. And now we suspect the story goes deeper still, perhaps all the way down to vibrating strings of energy smaller than we can ever hope to see directly. Black holes themselves were once considered too strange to be real. When Carl Schwarzschild first solved Einstein's equations in 1916 and found they predicted these regions where space and time would collapse into a point, even Einstein himself was skeptical. Surely nature wouldn't actually create such things. They seem like mathematical artifacts, quirks in the equations rather than descriptions of real objects that could exist out there among the stars. Yet as the decades passed, as our telescopes grew more powerful and our understanding more sophisticated, we began to see their signatures everywhere. Stars orbiting invisible companions with masses that defied explanation. X-rays screaming from the edges of dark regions where matter disappeared into seemingly nothing. And finally, gloriously, in 2019, we saw one directly, or at least we saw its shadow, its event horizon silhouetted against the glowing gas falling toward it, looking exactly as the equations had predicted it would look. But perhaps the most beautiful thing about black holes is not what we know about them, but what we don't know. Because once you cross that event horizon, once you pass that point of no return where not even light can escape back to tell us what it saw, the known laws of physics begin to break down, or at least our understanding of them does. We can describe with exquisite precision what happens outside a black hole, how space curves, how time dilates, how matter spirals inward in a gorgeous and terrifying dance. But inside is where our equations start producing infinities, where our computers throw up their hands in surrender, where even our imaginations struggle to paint a picture that makes sense. And it's precisely in that darkness, in that ultimate unknown, where tonight's beautiful possibility lives. Because if we don't know what happens inside a black hole, if our physics breaks down at that crucial point, then we can't definitively say what doesn't happen either. We can't rule out the possibility that something wonderful occurs in that hidden space, something that transforms an ending into a beginning, a collapse into a creation. Some of the brightest minds in physics have looked at those broken equations, those infinities that shouldn't exist, and wondered if they might be telling us not that physics fails, but that our perspective fails, that we're trying to describe from the outside something that can only be understood from within. Imagine for a moment, and I mean really imagine, let yourself sink into this thought as you might sink into a warm bath, that every black hole in our universe is quietly, secretly, giving birth to a new universe on its other side. Not in our space, not in our dimensions, but in some new space that buds off from ours like a bubble forming on the surface of a glass of champagne. From our perspective, we see only the black hole, only the point where light cannot escape, where matter disappears. But from another perspective, a perspective we cannot access, cannot measure, cannot visit, a whole new cosmos might be inflating, expanding, cooling, perhaps eventually forming its own galaxies, its own stars, its own planets, its own quiet nights where conscious beings lie back and wonder about the nature of their reality. The mathematics actually allows for this. That's the remarkable thing, the thing that transforms this from pure fantasy into scientific possibility. When physicists like Lee, Smolin, Nikodem Popławski and others have worked through the equations, when they've carefully traced what might happen to space and time inside a black hole, they've found solutions that describe exactly this. New universes budding from the collapse cores of stars. The math doesn't prove it happens, but it shows it could happen. And in physics, could is often the first step toward does. Think about what this would mean for our own universe, for our own existence. If black holes give birth to new universes, then our universe, the one we're floating in right now as you listen to these words, might itself have been born from a black hole in another parent universe. We might be living inside what was once a star in some unimaginably different cosmos, a star that lived and died and collapsed, and in collapsing created everything we've ever known. Every atom in your body, every photon of light from every star you've ever seen, every thought you've ever had might exist because somewhere, somewhen, in a universe we can never visit or see, a star reached the end of its life and fell inward, creating an outward we call home. This isn't just a poetic metaphor, though it certainly is poetic. This is a genuine scientific hypothesis, published in peer-reviewed journals, discussed at physics conferences, analysed with all the mathematical rigour that science demands. The idea has different names and slightly different versions: the black hole cosmology hypothesis, the cosmological natural selection theory, the multiverse of black holes. But they all share this central beautiful idea that what looks like an ending from one perspective might be a beginning from another, that destruction and creation might be the same process seen from different sides of an event horizon. As you lie there tonight, feeling your breath naturally slowing, your muscles releasing their grip on the day's tensions, you're participating in a universe that might be far more creative, far more abundant, far more generous with its realities than we ever suspected. Every black hole detected by our telescopes, from the stellar mass ones formed by dying stars to the supermassive giants at the centers of galaxies, might be a doorway, a birth canal, a seed from which new cosmos grow. Our Milky Way galaxy alone might contain millions of them, millions of potential universes, millions of realities that began where our physics says things should end. And here's where it gets even more wondrous, even more peaceful in its implications. If this is true, if black holes really do give birth to new universes, then creation isn't some singular event that happened once billions of years ago and never again. Creation would be happening constantly, continuously, quietly, throughout the cosmos. Right now, as you listen to these words, as your eyes grow heavy and your mind begins to float, new universes might be budding from black holes throughout our cosmos. Somewhere in the Andromeda galaxy, 2.5 million light years away but heading toward us in a cosmic dance that will take billions of years to complete, a star might be collapsing right now, and in its collapse, a universe might be born that will eventually harbour its own forms of beauty, its own kinds of consciousness, its own bedtime stories about the nature of existence. The gentleness of this idea, the quietness of it, stands in such beautiful contrast to how we usually think about black holes. Popular culture has painted them as cosmic monsters, devourers of light, destroyers of worlds, and yes, from our perspective, from our side of the event horizon, they are places where things disappear, where matter and energy take a one-way journey to somewhere we cannot follow. But if they're also doorways to new universes, then they're not monsters at all. They're more like cosmic seeds, or cosmic eggs, or cosmic wombs. They're places where the universe reproduces itself, creates new versions of itself, explores new possibilities of existence. Consider how this changes our relationship with the darkness we see when we look up at the night sky. That darkness isn't empty. We've known for a while now that it's full of dark matter and dark energy, substances we can't see but that shape the visible universe in profound ways. But if black holes are doorways to other universes, then that darkness might be even fuller than we thought. It might be pregnant with realities, heavy with possibilities, thick with universes we cannot see, but that exist as surely as our own exists. The ancient Greeks had a word, kenosis, which means self-emptying, the act of pouring oneself out. They used it to describe various forms of sacrifice and transformation. But what if kenosis is actually the fundamental creative act of the cosmos? What if stars empty themselves through collapse into black holes not as an ending but as the ultimate creative act, the way one universe pours itself into the possibility of another? What if the universe reproduces through a kind of cosmic kenosis, each generation giving birth to the next through the very act of stellar death and gravitational collapse? As we continue deeper into this exploration tonight, as we examine the evidence and the theories, the observations and the mathematics, I want you to hold this feeling, this sense of peaceful wonder at a cosmos that might be far more creative than we knew. Don't worry about understanding every detail, about following every equation, or remembering every fact. This isn't a test you need to pass or a puzzle you need to solve. This is an invitation to wonder, to float in possibility, to let your mind expand gently into spaces it doesn't usually explore. You know, there's something deeply comforting about the idea that our universe might not be alone, might not be the only expression of existence. Just as knowing that Earth isn't the only planet, that our sun isn't the only star, that our galaxy isn't the only galaxy, has helped us understand our place in a larger context, knowing that our universe might be one of countless universes, all connected through the mysterious doorways of black holes, gives us an even larger context, an even deeper sense of belonging to something magnificent. And if you're wondering whether any of this really matters to your daily life, to the challenges you face when you wake up tomorrow, to the work you need to do or the relationships you need to tend, consider this. Every great expansion of human understanding has begun with someone lying back, looking up, and wondering what if. Every technology we now take for granted, every comfort we enjoy, every piece of knowledge we use to navigate our world, started with someone willing to ask impossible questions and follow them wherever they led. The smartphone you might be listening to this on exists because people wondered what would happen if we could trap lightning in silicon. The medicine that keeps us healthy exists because people wondered what would happen if we could see the invisible world of bacteria and viruses. The warm bed you're lying in exists because someone wondered what would happen if we could capture and contain heat. So wondering whether black holes are doorways to other universes isn't just an abstract exercise in cosmic speculation. It's part of the grand human tradition of asking impossible questions that slowly, gradually, sometimes over generations, become possible answers. Your children or grandchildren might live in a world where traveling to other universes through black holes is discussed not as science fiction, but as engineering challenge. They might look back at us, at this moment in history, as the time when humanity first began to seriously consider that our universe might not be alone, might be part of a vast family of universes all connected through the dark doorways of collapsed stars. But for tonight, for right now, we don't need to worry about the practical applications or the distant future. We can simply rest in the wonder of it, in the possibility of it, in the strange and beautiful idea that destruction and creation might be two faces of the same cosmic process. As your breathing continues to slow, as your body continues to relax into wherever you're resting, you're participating in a universe that might be far more interesting than we ever dared to imagine. The stars above you tonight, whether you can see them or not, whether they're hidden by clouds or city lights, or the ceiling above your head, are engaged in this ancient dance of creation through destruction. Some of them, the massive ones, the giants and supergiants, will eventually collapse into black holes. And if our wandering tonight points toward truth, each of those collapses will be a birth, each of those endings will be a beginning, each of those deaths will be a doorway to new life on scales we can barely imagine. You are made of star stuff, as Carl Sagan famously said. The carbon in your DNA, the iron in your blood, the calcium in your bones, were all forged in the hearts of stars that died before our sun was born. But if black holes are doorways to new universes, then you might be made of something even more remarkable. You might be made of universe stuff, matter that has travelled not just from star to star, but from universe to universe, through the dark doorways of black holes, carrying with it some essential pattern, or memory, or tendency that connects all universes in an unbreakable chain of cosmic heredity. As we prepare to dive deeper into the science behind this beautiful possibility, into what we actually know about black holes and what they might be hiding, I want you to remember that you're not just a passive observer of this cosmic story, you're part of it. Your consciousness, your ability to wonder about these things, your capacity to imagine universes beyond our own, is the universe becoming aware of itself, contemplating itself, imagining its own possibilities. In a very real sense, when you wonder whether black holes are doorways to other universes, it's the universe wondering about its own nature, its own creative potential, its own mysterious depths. So settle in, dear listener, wherever you are in our shared cosmos tonight. Let your mind float free from the anchors of the everyday. Let yourself drift into this space of cosmic possibility, where the darkness isn't empty but full, where endings are beginnings, where every black hole might be a door to wonders we've only begun to imagine. We're about to explore what modern science actually knows about these cosmic mysteries, what our telescopes have seen, what our equations suggest, what our imaginations might be correctly intuiting about the true nature of reality. The journey we're taking tonight isn't just through space, but through possibility itself. We're going to travel from the familiar territory of what we know into the beautiful borderlands of what might be, guided by science but not limited by it, grounded in observation but free to soar into speculation. And through it all, remember that this is your journey too. These questions belong to you as much as they belong to any scientist or philosopher. The universe that might be birthing baby universes through black holes is your universe, your home, your cosmic inheritance. As we drift deeper into our cosmic contemplation tonight, Let's begin with what we actually know about these mysterious objects we call black holes, these regions of space that might, just might, be doorways to entire universes we cannot see. The story of our understanding begins not with dramatic observations through telescopes, but with quiet calculations on paper, with human minds wrestling with equations that seem to suggest something that shouldn't exist, something that violated our intuitions about how reality should behave. Yet the universe, as we've learned again and again, cares very little for our intuitions, preferring, instead, to be far stranger, far more wonderful than we expect. Picture, if you will, a star much like our Sun, but perhaps 20 or 30 times more massive, burning bright in some distant corner of our galaxy. For millions of years, this star maintains a delicate balance, a cosmic equilibrium between two opposing forces. Deep in its core, nuclear fusion creates an outward pressure, atoms slamming together with such force that they merge, releasing energy that pushes outward, trying to blow the star apart. But wrapped around this nuclear furnace is the star's own mass, its own gravity, pulling inward with equal determination, trying to crush everything down to a point. For most of a star's life, these forces balance perfectly, the outward push of fusion matching the inward pull of gravity, creating a stable sphere of plasma and light that can burn steadily for eons. But nothing lasts forever, not even stars. Eventually, inevitably, the fuel runs out. The hydrogen in the core gets used up, converted to helium. The helium fuses into carbon and oxygen. Heavier and heavier elements form in the stellar furnace until finally the star tries to fuse iron, and iron refuses to play along. Iron fusion doesn't release energy, it absorbs it. And in that moment, in less than a second, the balance that has held for millions of years catastrophically fails. Without the outward pressure of fusion to hold it up, the star collapses. Now, when we say collapse, we're not talking about something gentle or gradual. We're talking about the outer layers of the star falling inward at speeds approaching the speed of light. The core gets crushed down to densities that boggle the mind, densities where atomic nuclei are pressed against each other, where the normal empty space that makes up most of matter gets squeezed out. If the star is massive enough, not even the pressure of neutrons pressed against neutrons can stop the collapse. The matter just keeps falling inward, getting denser and denser, until something remarkable happens. Space and time themselves begin to curve so dramatically that they form a closed surface, a boundary from which nothing, not even light, can escape. This boundary, this point of no return, is what we call the event horizon. It's not a physical surface you could touch or land on. It's more like a border in space-time itself, a place where the curvature becomes so extreme that all paths, all possible futures, lead inward. From the outside, from our perspective safe here on Earth, or anywhere else in the universe outside the black hole, the event horizon appears to be a sphere of perfect darkness, a region from which no information can escape to tell us what lies within. But here's where our story tonight takes its first gentle turn toward wonder. Because while we can't see past the event horizon, while we can't receive any signals from inside a black hole, we can observe what happens around them, and what we've seen has transformed them from theoretical curiosities into confirmed inhabitants of our cosmos. The evidence has accumulated slowly, carefully, like sediment settling at the bottom of a cosmic ocean, building up layer by layer until the picture becomes undeniable. In the center of our galaxy, for instance, astronomers have spent decades watching stars dance. Not the slow, stately orbits we might expect, but wild, fast ellipses around an invisible point. One star, known simply as S2, swings around this invisible center every 16 years, reaching speeds of over 5,000 kilometers per second at its closest approach. By carefully tracking these stellar motions, astronomers have been able to calculate that whatever these stars are orbiting has a mass of about 4 million times that of our Sun, all concentrated in a region smaller than our solar system. There's only one thing we know of that could be so massive, yet so compact, so powerful, yet so invisible. A supermassive black hole sitting quietly at the heart of the Milky Way like a dark pearl in a cosmic oyster. And our galaxy is not unique in this regard. As our telescopes have grown more powerful, as our techniques have become more sophisticated, we've found that nearly every large galaxy has one of these monsters at its center. Some are even larger than ours, billions of times the mass of the Sun, so large that if you were to replace our Sun with one of them, its event horizon would extend past the orbit of Neptune. These supermassive black holes seem to be fundamental components of galaxies, not aberrations but essential parts of the cosmic architecture. But it's not just the giant black holes at galactic centers that we've found. Throughout our galaxy and others, we've detected stellar mass black holes, the remnants of individual massive stars that have undergone that catastrophic collapse we described earlier. We find them through their gravitational effects on companion stars, watching as visible stars orbit invisible partners. We detect them when they feed, when gas from a companion star spirals into them, heating up to millions of degrees and screaming in X-rays before disappearing forever past the event horizon. We've even, remarkably, gloriously, detected them through the ripples they create in space-time itself when they collide with each other. This last discovery, the detection of gravitational waves from merging black holes, deserves a moment of quiet appreciation. For 100 years after Einstein predicted that accelerating masses would create ripples in space-time, we couldn't detect them. They were too faint, too subtle, requiring instruments of almost impossible precision. But human ingenuity, human curiosity, human determination eventually prevailed. We built detectors that could measure distances smaller than the width of a proton, instruments so sensitive they could detect the stretching and squeezing of space itself as gravitational waves passed through Earth. And on September 14, 2015, we heard the universe sing a new song. The LIGO detectors picked up a signal that started low and rose in pitch and intensity before cutting off abruptly, a cosmic chirp lasting less than a second. When scientists analysed this signal, they found it matched perfectly with what Einstein's equations predicted for two black holes, each about 30 times the mass of our Sun, spiralling into each other and merging into a single, larger black hole. In that final moment of merger, these black holes released more energy in gravitational waves than all the stars in the observable universe were producing in light. Yet this tremendous event, this cosmic cataclysm, reached us as the gentlest of whispers, stretching and squeezing space by less than the width of an atomic nucleus. Since that first detection, we've heard dozens more of these cosmic chirps, each one telling us about black holes scattered throughout the universe, black holes of different masses, different spins, different histories. We've learned that black holes are not rare, exotic objects but common features of our universe, as fundamental to its structure as stars and galaxies. And with each detection, with each new piece of evidence, the possibility that these objects might be more than just endpoints, more than just cosmic graveyards, becomes more intriguing. You see, one of the most puzzling things about black holes is what physicists call the information paradox. According to quantum mechanics, information can never be truly destroyed. It can be scrambled, encrypted, transformed, but never eliminated entirely. Yet when something falls into a black hole, it seems to disappear completely, taking all its information with it. This contradiction between general relativity, which describes black holes, and quantum mechanics, which governs information, has been one of the great puzzles of modern physics. But what if the information doesn't disappear? What if it goes somewhere else, somewhere we can't see from our side of the event horizon? This is where our gentle speculation about baby universes begins to gain scientific traction. If each black hole connects to a new region of space-time, a baby universe budding off from our own, then the information that falls into the black hole doesn't disappear. It simply moves into this new universe, becoming part of its fundamental structure, its initial conditions, its cosmic DNA. Think about this slowly. Let it settle into your consciousness like starlight settling into a still pond. Every bit of matter that falls into a black hole, every photon of a light, every quantum of energy, might not be destroyed but transformed, becoming part of the seed from which a new universe grows. The atoms that once were part of stars, planets, perhaps even living beings, might become the fundamental building blocks of entirely new realities, new spaces and times, new possibilities for existence. This idea becomes even more beautiful when we consider what physicists have learned about the early moments of our own universe. According to our best theories, our universe began in a state of incredible density and temperature, a condition not unlike what we might find inside a black hole. In its first fraction of a second, our universe underwent a period of dramatic expansion called inflation, growing from something smaller than a proton to something larger than a grapefruit in less time than light could travel across an atomic nucleus. This inflation smoothed out the universe, made it flat and uniform on large scales, and planted the seeds for all the structure we see today. Now here's where the connection to black holes becomes particularly intriguing. Some physicists have calculated that the conditions inside a black hole, particularly a rotating black hole, could trigger exactly this kind of inflation. The intense curvature of space-time, the extreme densities, the isolation from the outside universe, all create an environment where a tiny region of space could suddenly inflate into a vast new cosmos. From our perspective outside the black hole, we would see nothing unusual, just matter falling past the event horizon and disappearing. But from a perspective we cannot access, a new universe might be born, expanding and cooling, perhaps eventually forming its own galaxies, stars, planets, and possibly life. The mathematics of this is surprisingly elegant. When physicists like Nikodem Popławski worked through Einstein's equations for the interior of rotating black holes, they found solutions that avoided the problematic singularity, that point of infinite density that our equations predict, but that most physicists believe cannot actually exist in nature. Instead, they found that matter falling into a rotating black hole could bounce, not back into our universe, but into a new expanding space-time, a baby universe connected to ours through the black hole but otherwise independent. This cosmic reproduction, if it really happens, would not be identical cloning. Each baby universe would potentially have slightly different properties from its parent. The fundamental constants of nature, things like the strength of gravity, the mass of electrons, the speed of light, might be slightly different in each new universe. This is because the conditions at the moment of formation, the exact state of the matter falling into the black hole, the spin of the black hole itself, would influence the properties of the baby universe. Lee Smolin, a theoretical physicist who has thought deeply about these ideas, has proposed that this could lead to a kind of cosmic natural selection. Universes that produce many black holes would have many offspring universes. If the offspring universes inherit slightly mutated versions of their parents' physical laws, and if some of these mutations make the universe more likely to produce black holes, then over cosmic time, we would expect universes to evolve towards states that are optimized for black hole production. Remarkably, our universe seems to be quite good at making black holes. The balance of forces, the values of fundamental constants, the way matter clumps together under gravity, all seem tuned to allow stars to form, live, die, and sometimes collapse into black holes. If the force of gravity were slightly stronger, stars would burn out too quickly to allow complex chemistry. If it were slightly weaker, stars might never ignite at all. We live in a universe that seems to be in a cosmic sweet spot for both black hole production and, interestingly, for the complexity that allows life to exist. This connection between black holes and life might not be coincidental. The same processes that allow stars to live long enough to create heavy elements necessary for planets and life, also allow some stars to eventually collapse into black holes. The same gravitational physics that allows matter to clump into galaxies, solar systems, and planets also allows it to collapse into black holes under the right conditions. We might exist not in spite of black holes, but because of them, because we live in a universe whose physical laws have been fine-tuned through cosmic evolution to be good at making both black holes and the conditions for life. As you lie there tonight, perhaps feeling your consciousness beginning to float between waking and sleeping, you're experiencing a universe that might be part of a vast family tree of cosmos, each one born from black holes in the previous generation, each one giving birth to new universes through its own black holes. Our universe might have cosmic parents, grandparents, ancestors stretching back through chains of black holes to some ultimate origin we can barely imagine. And it might have descendants, baby universes already budding from the millions of black holes scattered throughout our galaxies, each one starting its own journey toward complexity, structure, and perhaps consciousness. The gentleness of black holes, when viewed from this perspective, is profound. Yes, they are regions of extreme gravity, places where tidal forces could stretch you into spaghetti if you fell in, a process physicists call, with unexpected poetry, spaghettification. But this violence is only from our limited perspective, from our side of the event horizon. From another perspective, a perspective we cannot access but can imagine, they might be the gentlest things in the universe, cosmic wombs where new realities are tenderly nurtured into existence. Consider the black hole at the centre of our galaxy, that 4 million solar mass giant around which all the stars of the Milky Way, including our Sun, slowly orbit. Right now, as you listen to these words, it sits quietly in the darkness, occasionally snacking on a gas cloud that ventures too close, but mostly just existing, just curving space-time with its presence. If our speculation tonight is correct, it might be gestating a universe of unimaginable complexity, a cosmos that could eventually harbour billions of galaxies, trillions of stars, countless planets, and perhaps forms of consciousness we cannot imagine. And it's not alone. Throughout our galaxy, thousands, perhaps millions of stellar mass black holes drift through the darkness, each one formed from a star that once burned bright, fusing hydrogen into helium, helium into carbon, building the elements that would eventually become part of planets, part of life, part of you. And each one might now be a doorway to a new universe, a new exploration of what existence can be. The observational evidence for all of this remains indirect, circumstantial, like footprints in cosmic sand rather than direct sightings. We cannot travel to a black hole to test these ideas. We cannot send probes past an event horizon and expect to get data back. We cannot peek into these baby universes to see if they really exist. But we can observe how black holes affect the universe around them, how they bend light, how they influence the orbits of stars, how they merge and ring space-time like a bell. And everything we observe is consistent with them being not just simple regions of curved space-time, but potentially something far more profound. In 2019, humanity achieved something remarkable. The Event Horizon Telescope, actually a network of radio telescopes scattered around Earth, working together as a single planet-sized instrument, captured the first image of a black hole's event horizon. The target was a supermassive black hole in the galaxy M87, 55 million light-years away, with a mass of 6.5 billion suns. The image shows a bright ring of light surrounding a dark shadow, exactly what Einstein's equations predicted we would see. The light comes from gas swirling around the black hole, heated to billions of degrees, shining brilliantly before taking its final plunge past the event horizon. The dark shadow in the centre is the event horizon itself, the boundary beyond which light cannot escape. Looking at this image, the first time human eyes have seen the edge of a black hole, you might feel a mix of emotions. There's triumph, certainly, at the achievement of capturing such an image across 55 million light-years of space. There's awe at the scale of it, this object larger than our entire solar system. But there might also be a kind of cosmic vertigo, a dizzying sense of standing at the edge of the knowable, peering into a darkness that might hide entire universes. Because that darkness in the centre of the image, that shadow that light cannot escape, might not be empty. If our speculation tonight points toward truth, that darkness might be full, pregnant with possibilities, heavy with a universe that has already begun its expansion in dimensions we cannot perceive. The event horizon we see might be not just a boundary in space, but a boundary between universes, a cosmic membrane separating our reality from another that has just been born. The physics of how this might work involves some of the most cutting-edge ideas in theoretical physics. String theory, loop quantum gravity, and other attempts to unify general relativity with quantum mechanics all suggest that space and time might not be fundamental but emergent, arising from something deeper, more basic. In these theories, what happens at the event horizon of a black hole might involve a reorganization of these fundamental building blocks, a rearrangement that from one perspective looks like matter falling into oblivion, but from another perspective looks like the birth of new space and time. Some physicists have proposed that the event horizon might actually be a kind of hologram, a two-dimensional surface that encodes all the information about what has fallen into the black hole. This holographic principle, if correct, means that in some sense, everything that falls into a black hole remains encoded on its surface, never truly lost but transformed into a kind of cosmic memory written on the boundary between universes. The baby universe inside, if it exists, might then be a three-dimensional unpacking of this two-dimensional information, like a flower blooming from a seed. As we continue to observe black holes with ever more sophisticated instruments, we're finding that they're not the simple, featureless objects we once imagined. They spin, some of them at nearly the speed of light. They have magnetic fields, sometimes powerful enough to launch jets of particles across millions of light-years. They vibrate when disturbed, ringing like bells in frequencies we can now detect with gravitational wave observatories. Each of these properties might influence the nature of any baby universe born from them, like genetic traits passed from parent to offspring. The spin of a black hole, for instance, might determine the initial angular momentum of its baby universe, influencing how galaxies rotate billions of years later. The mass of the black hole might set the total energy available to the new universe, determining how large it can grow, how long it can expand before beginning to contract. The magnetic fields might influence the organization of matter in the early moments of the new universe, planting seeds that would eventually grow into the large-scale structure of galaxy clusters and cosmic voids. We're also discovering that black holes can merge, combining their masses, their spins, their event horizons into a single, larger black hole. When this happens, if baby universes really do exist inside black holes, what becomes of them? Do they merge as well, creating some kind of cosmic collision in dimensions we cannot see? Or do they remain separate, two universes now sharing a single connection to our cosmos? These questions stretch our imagination to its limits, yet they follow logically from the possibility we're exploring tonight. As your mind drifts with these ideas, as you feel yourself floating in this space between the known and the unknown, remember that you're not just thinking about abstract concepts or distant objects. You're contemplating the fundamental nature of existence itself, the possibility that reality is far richer, far more creative, far more abundant than we ever imagined. Every black hole we've detected, from the stellar mass ones in our own galaxy to the supermassive giants in distant quasars, might be a doorway to wonders beyond our current ability to explore, but not beyond our ability to imagine. And imagination, in science, is often the first step toward discovery. Before we detected gravitational waves, we imagined them. Before we saw black holes, we imagined them. Before we discovered that the universe was expanding, we imagined it might be. The human ability to wonder, to ask what if, to follow ideas to their logical conclusions, even when those conclusions seem impossible, has repeatedly revealed that the universe is stranger and more wonderful than we dared to believe. So as we float here together in this cosmic contemplation, as we consider the possibility that black holes are doorways to baby universes, we're participating in this grand tradition of human wondering. We're using our consciousness, itself perhaps the strangest thing in the universe, to contemplate the universe's own creative potential. We're asking whether the cosmos might be not a single, isolated existence, but a thriving family of realities, all connected through the dark doorways of black holes, all exploring different possibilities of what it means to exist. There's something deeply human about standing at edges, isn't there? We're drawn to shorelines where ocean meets land, to mountain peaks where earth meets sky, to those liminal spaces where one thing becomes another. Tonight, as you settle deeper into rest, as your breathing continues its slow rhythmic pattern, we're going to explore the ultimate edge, the most profound boundary in all of physics, the event horizon of a black hole. But we're going to think about it not as a barrier, but as a doorway, not as an ending, but as a transformation, not as a wall, but as a veil between realities. Imagine standing at the edge of a vast ocean at night. You can see the waves nearby, illuminated perhaps by moonlight, or the faint glow from distant cities. You can hear the water lapping at the shore, feel the salt spray on your face. But beyond a certain distance, the ocean disappears into darkness. You know it continues. You know there are depths and distances beyond your perception, but from where you stand, there's a horizon beyond which you cannot see. This oceanic horizon is just a limitation of your perspective, a consequence of your position and the curvature of Earth. If you could rise high enough, fly far enough, the horizon would recede, revealing more ocean, more waves, more wonders. But the event horizon of a black hole is different. It's not just a limitation of perspective that could be overcome with better position or better instruments. It's a fundamental boundary written into the fabric of space-time itself, a point beyond which the very concepts of beyond and outside cease to have meaning in the way we understand them. It's as if the ocean we were imagining didn't just disappear into darkness, but into an entirely different kind of existence, a place where water isn't water anymore, where waves aren't waves, where the very nature of reality transforms into something we can barely imagine. The word horizon comes from the Greek word horizon, meaning to bound or to limit. But what if the event horizon of a black hole is less a limit and more a transformation? What if it's not where things end but where they change state, like water becoming steam, like caterpillars becoming butterflies, like seeds becoming trees? This is the gentle speculation we're exploring tonight, the possibility that the event horizon is not a destroyer but a transformer, not a grave but a gateway. To understand this possibility, we need to think carefully about what actually happens at an event horizon, and here we encounter one of the most beautiful paradoxes in physics. From the perspective of someone falling into a black hole, nothing special happens at the event horizon. You would pass through it without noticing, without feeling any sudden force or barrier. The curvature of space-time is smooth and continuous. You would continue falling toward the center of the black hole, and from your perspective, you would pass the event horizon in finite time, perhaps even fractions of a second for a supermassive black hole. But from the perspective of someone watching from outside, something very different happens. As you approach the event horizon, time dilation becomes extreme. You appear to slow down, your movements becoming more and more sluggish. The light from you becomes red-shifted, stretched to longer and longer wavelengths. To the outside observer, you never quite reach the event horizon. Instead, you appear to freeze at its edge, your image fading to black as the light from you becomes too red-shifted to detect. From the outside perspective, you remain frozen at the horizon forever, never quite crossing, never quite disappearing. This paradox, this contradiction between what the falling observer experiences and what the outside observer sees, hints at something profound about the nature of reality at event horizons. It suggests that the event horizon is not just a place, but a kind of cosmic translator, a boundary where different perspectives, different realities, different truths can coexist without contradiction. What looks like falling from one perspective looks like freezing from another. What looks like crossing from inside looks like approaching but never arriving from outside. Now, let's add our speculation about baby universes to this picture. If a black hole really does give birth to a new universe in its interior, then the event horizon becomes even more remarkable. It becomes the boundary not just between the inside and outside of a black hole, but between two entirely different universes, two different spacetimes, two different realities. The paradox of the falling observer takes on new meaning. From our universe's perspective, matter falls toward the horizon and freezes there. From the baby universe's perspective, that same matter might be emerging as the fundamental energy that drives cosmic inflation, the rapid expansion that creates space and time in the new cosmos. Think about this slowly. Let it percolate through your consciousness like water through coffee grounds, extracting meaning gradually. Every atom that falls toward a black hole in our universe might simultaneously be becoming part of the initial conditions of a new universe. The event horizon might be performing a kind of cosmic alchemy, transforming matter and energy from one form of existence to another, from participants in our cosmos to seeds of a new one. This idea becomes even more intriguing when we consider what physicists have learned about the nature of space and time near event horizons. In our everyday experience, space and time seem distinct. Space is where things happen. Time is when they happen. We can move freely through space in any direction, but we're carried through time in only one direction, always forward, never back. But near a black hole, this familiar distinction begins to break down. Space becomes time-like, time becomes space-like, and the familiar categories we use to organize our experience of reality begin to blur and merge. Inside the event horizon, the radial direction, the direction toward the center of the black hole, becomes time-like. Just as we cannot travel backward in time in our normal experience, an observer inside the event horizon cannot travel outward. They must move toward the center, not because of any force compelling them, but because the geometry of space-time itself allows no other possibility. The center of the black hole lies in their future as inevitably as tomorrow lies in ours. But what if that inevitable future, that center toward which everything inside the horizon must travel, is not a point of destruction, but a point of transformation? What if it's where our space-time connects to a new space-time, where the umbilical cord between universes is attached? The matter falling toward the center wouldn't be crushed out of existence, but would pass through a cosmic birth canal into a new form of existence, becoming the primordial energy of a baby universe. Some physicists have calculated that this transformation might happen through what they call a white hole, the time-reversed version of a black hole. While a black hole is a region that nothing can escape, a white hole would be a region that nothing can enter, only exit. From our universe's perspective, we see only the black hole, the region where things fall in. From the baby universe's perspective, they might see only a white hole, a point from which energy and matter emerge to create their cosmos. The event horizon would be the boundary between these two perspectives, the place where black becomes white, where ending becomes beginning, where death becomes birth. The geometry of this is fascinating to contemplate. Our three-dimensional space plus one-dimensional time might connect to the baby universe's space-time through a kind of cosmic throat, a bridge between realities that exist not in our dimensions but in some higher dimensional space we cannot directly perceive. Imagine two soap bubbles touching. From inside each bubble, the surface looks complete, unbounded. But from outside, we can see where they connect, where one bubble becomes another. The event horizon might be like that point of connection, invisible from inside either universe, but representing a profound link between them. This hidden room quality of black holes, this sense that they contain spaces we cannot see, volumes we cannot measure, realities we cannot access, makes them perhaps the most mysterious objects in our universe. We can measure their mass by how they affect nearby stars. We can measure their spin by how they drag space-time around with them. We can measure their size by the diameter of their event horizons. But we cannot measure what's inside. We cannot send probes past the event horizon and get data back. We cannot peek behind the veil to see what lies beyond. In a sense, every black hole is like a locked room in the cosmic house, a space we know exists but cannot enter, cannot explore, can only imagine. And just as a locked room in a house might contain treasures or mysteries or simply another room much like the ones we know, the interior of a black hole might contain wonders beyond our imagination or simply more space and time arranged in ways we cannot access. The information paradox we mentioned earlier takes on new dimensions when we think about event horizons as boundaries between universes. Stephen Hawking famously showed that black holes should emit radiation, a gentle glow of particles created by quantum effects near the event horizon. This Hawking radiation, as it's called, would cause black holes to slowly evaporate over vast spans of time, eventually disappearing entirely. But if the information that fell into the black hole is truly destroyed when the black hole evaporates, it would violate the fundamental principles of quantum mechanics. However, if the information doesn't disappear but instead passes into a baby universe, the paradox might be resolved. The information wouldn't be destroyed, it would simply be elsewhere, in another cosmos we cannot access. The event horizon would act like a one-way valve, allowing information to flow from our universe to the baby universe but not back. This would preserve the total information content of reality, just spread across multiple universes rather than confined to one. Recent theoretical work has suggested even more, subtle possibilities. Perhaps the information that falls into a black hole becomes encoded on the event horizon itself, spread across its surface in a kind of holographic code. This holographic principle suggests that all the three-dimensional information that falls into a black hole might be preserved as a two-dimensional pattern on the horizon, like a shadow that contains all the information about the object that cast it. If this is true, then the event horizon is even more remarkable than we imagined. It's not just a boundary, but a kind of cosmic hard drive, storing the information of everything that has ever fallen past it. And if baby universes really do bud from black holes, this information might serve as the genetic code for the new cosmos, determining its properties, its physical laws, its potential for complexity and life. Think about what this means for the black holes we observe in our universe. The supermassive black hole at the center of our galaxy has been feeding for billions of years, swallowing gas clouds, stars, perhaps even smaller black holes. All of that matter, all of that information, might now be encoded on its event horizon, a vast library of cosmic history written in a language we cannot yet read. And if our speculation is correct, all of that information might be unfolding into a baby universe, becoming the stars and galaxies, and perhaps even the life of a cosmos we will never see, but that owes its existence to our universe's history. The event horizon also raises profound questions about the nature of reality itself. In our everyday experience, we think of boundaries as thin, perhaps infinitesimally thin, surfaces separating one region from another. But the event horizon of a black hole might not be thin at all. Some theories suggest it might have a kind of thickness, a fuzzy region where quantum effects create a foam of microscopic black holes and wormholes, a turbulent zone where space and time themselves become uncertain. This fuzzy horizon, or firewall, as some physicists call it, might be where the transformation from our universe to a baby universe actually occurs. It might be a kind of cosmic factory, taking the raw materials of matter and energy from our universe and processing them into the initial conditions for a new cosmos. The fuzziness, the quantum uncertainty, might be essential to this process, providing the randomness necessary for each baby universe to be slightly different from its parent, allowing for cosmic evolution and diversity. As you lie there, perhaps feeling yourself drifting closer to sleep, your consciousness becoming fuzzy like these theoretical horizons, you're experiencing your own kind of boundary state. The edge between waking and sleeping is its own event horizon, a place where the normal rules of consciousness begin to break down, where time becomes elastic, where the impossible becomes possible in dreams. And just as the event horizon of a black hole might be a gateway to new universes, your passage into sleep is a gateway to the universe of dreams, a realm with its own logic, its own physics, its own possibilities. Consider how perfectly the event horizon embodies the theme of hiddenness, of mystery, of the unknown that pervades our universe. We live in a cosmos where 95% of the energy and matter is dark, invisible, known only through its gravitational effects. We live on a planet where the deep oceans remain largely unexplored, where the ground beneath our feet hides layers of history going back billions of years. We live in bodies where consciousness emerges from neural activity in ways we don't fully understand, where the transition from non-living chemistry to living biology remains one of science's great mysteries. Event horizons are perhaps the ultimate expression of this cosmic hiddenness. They are boundaries beyond which our physics, our instruments, our very concepts of knowledge break down. They remind us that the universe is under no obligation to be fully comprehensible to human minds, that there might always be rooms we cannot enter, depths we cannot fathom, realities we cannot access. Yet the fact that we can theorize about what lies beyond event horizons, that we can use mathematics and physics to speculate about baby universes and cosmic reproduction, shows that human imagination and intellect can sometimes reach beyond what our physical bodies can explore. We are, in a sense, using consciousness to probe regions where consciousness, at least as we know it, cannot go. We are using thought to explore the unthinkable, using reason to map the boundaries of reason itself. The event horizons in our universe might be telling us something profound about the nature of existence. They might be showing us that reality is not a single, continuous, fully accessible whole, but rather a collection of regions, some accessible, some hidden, some connected in ways we're only beginning to imagine. Each black hole might be a reminder that our universe, vast as it seems, might be just one room in an infinite cosmic house, one bubble in an endless foam of realities. And if this is true, if event horizons really are gateways to other universes, then our cosmos is far more creative, far more abundant, far more generous with existence than we ever imagined. Every second, somewhere in our universe, matter is crossing an event horizon. Every second, if our speculation is correct, new universes are being born. New realities are beginning their journeys toward complexity and perhaps consciousness. The universe isn't just expanding, it's reproducing, creating new versions of itself, new explorations of what it means to exist. The ancient mystics spoke of veils between worlds, boundaries between the seen and unseen, the known and unknown. They intuited what modern physics is now suggesting with mathematical precision, that reality has hidden depths, secret rooms, boundaries beyond which ordinary perception cannot penetrate. The event horizons of black holes might be the physical manifestation of these mystical veils, the places where science and mystery meet, where the known universe touches the unknown. As we prepare to journey deeper into the implications of this idea, into what it might mean for our understanding of our own universe's origin and destiny, let the image of the event horizon settle into your mind. Picture it not as a barrier, but as a membrane, not as an ending, but as a transformation, not as a destruction, but as a doorway. Every black hole in our universe, from the stellar mass ones formed by dying stars to the supermassive giants at the hearts of galaxies, might be surrounded by these remarkable boundaries, these cosmic horizons where one reality becomes another. The darkness of a black hole, when viewed from this perspective, is not the darkness of emptiness but the darkness of hiddenness, like the darkness inside a seed before it germinates, like the darkness of a womb where new life grows unseen. The event horizon hides not nothing but everything, not absence but potential, not ending but beginning. It's the universe's way of keeping some of its creative processes private, hidden from view, protected from interference. And perhaps that's as it should be. Perhaps some mysteries are meant to remain mysterious, some boundaries are meant to remain uncrossed, some rooms are meant to remain hidden. The event horizon teaches us humility, reminds us that our knowledge, vast as it has become, is still limited, that there are aspects of reality we may never fully understand. But it also teaches us wonder, shows us that the universe is far stranger, far more creative, far more magnificent than we imagined. As your consciousness continues to drift, as you float in that borderland between waking and sleeping, you're approaching your own event horizon for tonight, the boundary beyond which dreams await. And just as matter, crossing a black hole's event horizon, might seed a new universe, the thoughts and wonderings you've absorbed tonight might seed new dreams, new insights, new ways of understanding your place in the cosmos. The boundary you're approaching is not an ending but a transformation, not a loss of consciousness, but a change in consciousness, not a departure from reality but an entry into a different kind of reality. In the next phase of our journey, we'll explore what these baby universes might actually be like, how they might form, grow and evolve, and what their existence might mean for our understanding of our own cosmic origins. But for now, rest with the image of event horizons as hidden rooms, as cosmic doorways, as the places where the universe keeps its deepest secrets and performs its most profound transformations. Rest with the knowledge that you live in a cosmos far more mysterious, far more creative, far more abundant than we ever dared to imagine. Now we arrive at the heart of our cosmic contemplation, the central mystery that has drawn us together tonight beneath this canopy of stars and possibilities. What if, just what if, every black hole in our universe is quietly, secretly, giving birth to an entirely new cosmos? Not in our space, not in our dimensions, but in some new realm that buds off from ours like a soap bubble, forming on the surface of another bubble, connected for a moment before drifting free into its own existence. This isn't science fiction, though it might sound like it. This is a genuine scientific hypothesis, explored in peer-reviewed papers, discussed at physics conferences, calculated with all the mathematical rigor that modern cosmology demands. To understand how a baby universe might be born inside a black hole, we need to journey back to the beginning of our own universe, to those first impossibly hot, impossibly dense moments when everything we see today, every galaxy, every star, every atom in your body was compressed into a region smaller than the smallest particle we can imagine. Our universe began, according to our best theories, in a state remarkably similar to what we might find inside a black hole. Extreme density, extreme curvature of space-time, extreme temperature. The main difference, the crucial difference, is that our universe was expanding from the very beginning, while matter inside a black hole appears to be contracting. But appearances, as we've learned throughout our exploration tonight, can be deceiving. What looks like contraction from one perspective might look like expansion from another. What seems to be falling inward from outside the event horizon might be exploding outward in dimensions we cannot perceive. This is the beautiful, mind-bending possibility that physicists like Lee Smolin, Nikodem Popowski, and others have been exploring. That the collapse of matter in a black hole might trigger the birth of a new expanding universe, invisible to us, but as real and vast as our own. The mechanism for this cosmic reproduction might involve something called a bounce. Instead of matter crushing down to an infinite density at the center of the black hole, a point that physicists call a singularity, and that most believe cannot actually exist in nature, the matter might reach some maximum density and then rebound, not back into our universe but into a new set of dimensions, a new space-time that begins expanding from that moment of maximum compression. It's like squeezing a spring until it can compress no more, and then instead of bouncing back, it bounces sideways into a dimension you couldn't see before, expanding in a direction that didn't previously exist. This bounce might be triggered by quantum effects that become important at extremely high densities. In our everyday world, quantum mechanics governs the very small, while general relativity governs the very large, and rarely do the two domains overlap. But inside a black hole, especially near its center, matter becomes so compressed that quantum effects can't be ignored even though we're dealing with the curved spacetime of general relativity. This marriage of quantum mechanics and gravity might prevent the formation of a true singularity, replacing it instead with a quantum bounce that births a baby universe. The mathematics of this is beautiful in its elegance. When physicists work through Einstein's equations for the interior of a rotating black hole, including quantum corrections, they find that the collapsing matter doesn't reach infinite density. Instead, it reaches a maximum density determined by the fundamental scales of quantum gravity, perhaps the Planck density, where a cubic Planck length of space contains a Planck mass of matter. At this density, space and time themselves become quantum mechanical, fuzzy, uncertain. And in this quantum foam, this turbulent sea of uncertainty, a new universe can nucleate, can begin its own expansion, its own journey toward galaxies and stars and possibly life. Think about what this means for a moment. Let it really sink into your consciousness like rain, into thirsty soil. Every black hole in our universe, and there are millions of them in our galaxy alone, billions of them in the observable universe, might contain within it an entire cosmos as vast and complex as our own. The stellar mass black hole formed from a collapsed star might harbour a universe with billions of galaxies. The supermassive black hole at the centre of a galaxy might contain a universe with trillions of galaxies. Each of these universes would be invisible to us, hidden behind the event horizon, but they would be as real, as physical, as filled with energy and matter and possibility as the universe we inhabit. And here's where it gets even more wonderful. Each of these baby universes wouldn't be an exact copy of our universe. The physical constants, what we call the fundamental parameters of nature, might be slightly different in each one. The strength of gravity might be a bit stronger or weaker. The mass of the electron might be slightly different. The speed of light might be faster or slower. These differences would arise from the specific conditions at the moment of the black hole's formation: its mass, its spin, its electric charge, the properties of the matter falling into it. Each black hole would produce a unique baby universe, a new experiment in what physics allows, what chemistry permits, what biology might achieve. Lee Smolin has proposed that this could lead to a kind of cosmic natural selection, the evolution of universes through black hole reproduction. Universes that are good at making black holes would have many offspring. If the offspring inherit slightly mutated versions of their parents' physical laws, and if some of these mutations make black holes even more likely, then over cosmic generations universes would evolve to be increasingly fecund, increasingly good at making black holes, and remarkably, wonderfully, the conditions that make a universe good at. Producing black holes might also be the conditions that make it good at producing complexity, chemistry, and life. This is because black holes require a delicate balance of forces and constants. If gravity is too strong, matter collapses too quickly, stars burn out in moments, and there's no time for the slow stellar evolution that creates heavy elements. If gravity is too weak, matter never clumps together enough to form stars at all, let alone black holes. If the nuclear forces are wrong, stars might never ignite, or they might explode immediately, or they might burn forever without ever creating the heavy elements necessary for planets and life. Our universe seems to sit in a sweet spot where stars can form, live for billions of years creating heavy elements, and then sometimes collapse into black holes. And this same sweet spot allows for rocky planets, complex chemistry, and the emergence of life. So we might exist not by cosmic accident, but by cosmic evolution. Our universe might be successful at producing life precisely because it's successful at producing black holes. We might be a side effect, a beautiful consequence, of our universe's reproductive fitness. Every time a massive star collapses into a black hole in our galaxy, it might be creating a new universe that could eventually harbour its own forms of life, its own consciousness, its own beings lying under their own night sky wondering about their origins. The energy available to these baby universes would be enormous. When matter falls into a black hole, it carries with it not just its rest mass energy, the EMC2 that Einstein made famous, but also its kinetic energy, its gravitational potential energy, its pressure, its heat. All of this energy would become available to the baby universe as its initial endowment, its cosmic seed money. A stellar mass black hole might birth a universe with the energy equivalent of several suns. A supermassive black hole might birth a universe with the energy of billions of suns. This energy would drive the initial expansion, the cosmic inflation that would create space and time in the new universe. The rotation of the black hole might be particularly important. Most black holes in our universe are thought to be rotating, some of them at speeds approaching the speed of light at their event horizons. This rotation would be inherited by the baby universe as a kind of cosmic angular momentum, possibly determining how galaxies would rotate billions of years later in the offspring cosmos. A rapidly rotating black hole might produce a universe where galaxies spin faster, where spiral arms are wound tighter, where the dynamics of star formation are subtly different. A slowly rotating black hole might produce a more sedate universe, with lazily turning galaxies and different patterns of cosmic structure. As you lie there, perhaps feeling your own gentle rotation with the Earth as our planet spins through the night, you're participating in angular momentum that can be traced back through a chain of conservation to the early universe, perhaps even to the rotation of the black hole that gave birth to our cosmos. Every spin, every rotation, every orbit in our universe might be an echo of that initial angular momentum, a cosmic inheritance from our parent black hole. The matter falling into black holes in our universe is not primordial hydrogen and helium from the Big Bang. It's enriched matter, processed through generations of stars containing heavy elements like carbon, oxygen, iron, all the elements necessary for complexity and life. If this matter becomes the seed material for baby universes, then those universes start with a richer palette of elements than our universe had at its beginning. They might achieve complexity faster, might develop life sooner, might explore possibilities of chemistry and biology that took our universe billions of years to discover. Imagine a universe born from a black hole that has swallowed planets, asteroids, comets, perhaps even the debris of technological civilizations. The information content of all the organized matter wouldn't be destroyed but would become part of the initial conditions of the baby universe. While it would be scrambled, processed, transformed beyond recognition, it would still influence the new cosmos in subtle ways. The baby universe would carry within its fundamental structure the ghost of everything that fell into its parent black hole. This raises profound questions about information and causality across universes. If baby universes really exist inside black holes, then information from our universe influences theirs, but information from their universe cannot flow back to ours. It's a one-way street, a cosmic valve that allows causality to flow in only one direction. This might be necessary to prevent paradoxes, to keep the universes causally separate even though they're connected through the black hole. But there might be subtle ways that baby universes could influence their parents. Some physicists have speculated that the properties of baby universes might affect the evaporation rate of their parent black holes through quantum effects. A black hole with a thriving baby universe inside might evaporate slightly differently than one without. These differences would be incredibly tiny, far beyond our current ability to measure, but they might exist nonetheless, a whisper from the baby universe to its parent, a sign that something wonderful is happening beyond the event horizon. The formation of a baby universe might happen incredibly quickly from the black hole's perspective, but take billions of years from the baby universe's internal perspective. This is because time itself would be created fresh in the baby universe, with its own rate of flow, its own cosmic clock. What seems like seconds in the black hole might be eons in the baby universe. A stellar mass black hole that forms, exists, and evaporates over trillions of years in our universe might give birth to a baby universe that experiences hundreds of billions of years of internal time, enough for countless generations of stars, for the rise and fall of countless civilizations, for stories and histories we can barely imagine. As we contemplate these possibilities, as we let our minds expand to encompass universes within universes, realities within realities, it's natural to feel a kind of cosmic vertigo. The scale of what we're discussing, the implications for our understanding of existence can be overwhelming. But remember, you don't need to grasp it all, don't need to hold it all in your mind at once. Like the universe itself, understanding can expand gradually, can grow from a tiny seed of wonder into a vast tree of knowledge, given time and patience. The observational evidence for baby universes remains indirect, circumstantial, like seeing footprints in the snow and inferring the creature that made them. We cannot see inside black holes, cannot visit baby universes, cannot directly confirm their existence. But we can look for subtle signs, statistical patterns, anomalies that might hint at their presence. For instance, if cosmic natural selection is real, we would expect the constants of nature in our universe to be near optimal for black hole production. And indeed, many physicists have noted that our universe does seem remarkably well tuned for making black holes. We can also look for signatures in the cosmic microwave background, the afterglow of the Big Bang that might indicate our universe was born from a black hole. Some physicists have suggested that certain patterns in this radiation, certain anomalies in its temperature distribution, might be fossils from our universe's birth inside a parent black hole. These patterns would be incredibly subtle, requiring measurements of extraordinary precision, but they might be detectable with future instruments. Another possibility is that baby universes might occasionally reconnect with their parent universe through quantum effects, creating what physicists call wormholes or Einstein-Rosen bridges. These would be shortcuts through space-time, tunnels connecting distant regions of space, or even different universes. While large, traversable wormholes remain in the realm of speculation, microscopic quantum wormholes might exist, allowing tiny amounts of information or energy to leak between universes. These connections would be far too small for anything macroscopic to pass through, but they might allow for subtle quantum correlations between parent and child universes. The philosophical implications of baby universes are as profound as the scientific ones. If every black hole contains a universe, then our cosmos is not alone but part of a vast, possibly infinite family of universes, all connected through the branching tree of black hole reproduction. We would be living not in the universe but in a universe, one among countless others, each exploring different possibilities of physics, chemistry, and perhaps consciousness. This multiverse wouldn't be the parallel universes of science fiction, where alternate versions of ourselves make different choices. These would be genuinely different universes with different laws of physics, different constants of nature, different possibilities for existence. In some, atoms might not be stable, in others stars might burn too fast or too slow for life. But in some, perhaps many, conditions might be just right for forms of complexity and consciousness we can't imagine, beings and civilizations that would seem like magic to us, just as our technology would seem like magic to our ancestors. The idea that we might be living inside a black hole in another universe is both humbling and elevating. Humbling because it means our entire cosmos, everything we've ever known or ever will know, might be just a tiny part of a much larger reality. Elevating because it means we're part of a cosmic process of creation that transcends individual universes, a chain of causation and creation that might extend infinitely in both directions without beginning or end. As you drift deeper into rest tonight, as your consciousness begins its nightly journey toward dreams, you might imagine yourself not just as a collection of atoms arranged in a particular pattern, but as part of this cosmic reproductive process. The atoms in your body, forged in the hearts of stars, might have travelled not just through space, but through universes, passing through black holes and white holes, participating in countless cosmic births and rebirths. You're not just star stuff, but universe stuff, matter that has perhaps travelled through dimensions and realities beyond counting. And the thoughts you're thinking right now, the consciousness you're experiencing, might not be unique to our universe. If the conditions for consciousness can arise in our cosmos, they might arise in baby universes too, in different forms, with different substrates, but with the same fundamental capacity for awareness, for wonder, for contemplation of existence. Across the multiverse of black hole-born universes, countless forms of consciousness might be awakening to their existence, asking their own questions about their origins, perhaps even speculating about whether they might be living inside a black hole in a parent universe. The gentleness of this cosmic reproduction, the quietness of it, stands in beautiful contrast to the violence we usually associate with black holes. Yes, the formation of a black hole involves the collapse of a star, temperatures of billions of degrees, forces that could tear atoms apart. But the birth of the baby universe, if it happens, might be as gentle as a seed germinating, as quiet as a thought forming, as peaceful as falling asleep. The new universe would begin its expansion not with violence but with a kind of cosmic exhalation, space itself breathing into existence, time beginning its steady heartbeat. This process might be happening right now, all around us, throughout our universe. As you listen to these words, massive stars might be collapsing into black holes in distant galaxies, each collapse potentially triggering the birth of a new universe. The cosmic birth rate might be thousands of universes per second, each one beginning its own journey toward complexity, its own exploration of what existence can be. The universe isn't just expanding, it's reproducing, proliferating, exploring every possible variation of itself, and each of these baby universes would eventually produce its own black holes, its own offspring, its own contribution to the ever-growing tree of cosmic existence. The generations would cascade, universes giving birth to universes giving birth to universes, each generation potentially more complex, more fecund, more capable of producing both black holes and consciousness. The multiverse wouldn't be static, but evolving, growing, becoming ever more rich and varied with each cosmic generation. From our small vantage point here on Earth, a tiny world orbiting an ordinary star in an unremarkable galaxy, we might seem hopelessly limited in our ability to explore these cosmic mysteries. How can we, bound to this one planet, trapped in this one universe, ever hope to detect baby universes hidden behind event horizons? How can we find evidence for realities we cannot visit, cannot see, cannot directly measure? Yet human ingenuity, human curiosity, human determination to understand our place in the cosmos has repeatedly achieved what seemed impossible. We've weighed stars we cannot touch, measured distances we cannot travel, detected particles we cannot see, and now, perhaps, we're beginning to glimpse signs of universes we cannot visit. The evidence, such as it is, comes to us in whispers rather than shouts, in subtle patterns rather than obvious signals, in statistical anomalies rather than direct observations. But science has always been about reading subtle clues, about inferring the existence of things we cannot directly perceive from their effects on things we can perceive. We discovered atoms before we could see them, deduced the existence of other galaxies before we could resolve them, predicted black holes before we could detect them. The possibility of baby universes follows this same pattern. First comes the theoretical prediction, then the search for indirect evidence, and perhaps someday, though maybe not in our lifetimes, more direct confirmation. Let's begin with what we can actually observe, with the remarkable instruments humanity has built to peer into the cosmic darkness and listen to the universe's subtle songs. The Event Horizon Telescope, which gave us our first image of a black hole's shadow, is really a network of radio telescopes scattered across Earth, from Antarctica to Arizona, from Chile to Spain. By combining their observations using a technique called very long, baseline interferometry, these telescopes work together as a single Earth-sized instrument, achieving the resolution necessary to see the event horizon of a black hole millions of light years away. That first image, of the supermassive black hole in the galaxy M87, shows a ring of light surrounding a dark shadow. The light comes from gas swirling around the black hole, heated to billions of degrees, shining brilliantly in its final moments before crossing the event horizon. The dark shadow in the center is the event horizon itself, or rather the region from which no light can escape to reach our telescopes. Looking at this image is like looking at the doorway to another universe, if our speculation tonight is correct. That darkness might not be empty but full, pregnant with a cosmos we cannot see. Since that first image, the Event Horizon Telescope has also captured our own galaxy's central black hole, Sagittarius A, a monster of 4 million solar masses sitting just 26,000 light-years away. This image was harder to obtain because our black hole is smaller and the gas around it changes more quickly, like trying to photograph a puppy that won't sit still compared to a sleeping cat. But the image shows the same telltale structure, a bright ring of doomed gas surrounding a dark shadow, another possible doorway to another universe. These images confirm predictions made by Einstein's general relativity with remarkable precision. The size of the shadow, the brightness of the ring, the way the light is distributed around the black hole all match what the equations say they should be. This agreement between theory and observation gives us confidence that we understand black holes, at least from the outside. But it's what we can't see, what's hidden behind that dark shadow, where the possibility of baby universes lives. The LIGO and Virgo gravitational wave detectors have given us another window into the world of black holes, allowing us to hear them rather than see them. These instruments are marvels of precision engineering, able to detect changes in distance smaller than 1,000th of the diameter of a proton. They work by splitting a laser beam and sending it down 2 perpendicular arms, each 4 kilometers long. When a gravitational wave passes through Earth, it stretches space in one direction and compresses it in the perpendicular direction, causing the laser beams to travel slightly different distances, creating an interference pattern that reveals the passing wave. Since 2015, these detectors have heard dozens of black holes merging, each event sending ripples through space-time that travel for millions or billions of years before washing over Earth as the gentlest of whispers. Each detection tells us about the masses of the merging black holes, their spins, their distance from us. But more than that, these observations have revealed a population of black holes we didn't know existed. Intermediate mass black holes, larger than those, formed from single stars but smaller than the monsters at galaxy centers. If baby universes are real, each of these merging black holes might involve the collision of entire cosmos, realities coming together in ways we can barely imagine. When 2 black holes merge, their event horizons combine into a single, larger horizon. If each black hole contains a baby universe, what happens when they merge? Do the universes combine? Do they remain separate but now share a common boundary with our universe? These questions push our imagination to its limits, yet they follow logically from the possibility we're exploring. The James Webb Space Telescope, humanity's newest eye on the cosmos, has been revealing the early universe in unprecedented detail. It has found galaxies that formed earlier than we expected, black holes that grew larger faster than our models predicted. Some of these early supermassive black holes seem to have formed when the universe was only a few 100 million years old, reaching masses of millions or billions of suns in what seems like cosmic blink of an eye. These observations might be telling us something important about our universe's own origin. If our cosmos was born from a black hole in a parent universe, it might have inherited certain properties that made black hole formation easier, faster, more efficient than in a universe that arose spontaneously. The abundance of early black holes might be a clue, a hint that our universe is optimized for black hole production because it was born from a black hole, inheriting traits that make it good at producing its own offspring. The cosmic microwave background radiation, the afterglow of the Big Bang, might contain even more subtle clues. This radiation fills all of space, a faint whisper of heat left over from when the universe was young and hot. It's remarkably uniform, the same temperature everywhere to within a few parts in 100,000. But those tiny variations, those slight differences in temperature from one part of the sky to another, contain a wealth of information about the early universe. Some physicists have suggested that if our universe was born from a black hole, there might be specific patterns in the cosmic microwave background that would reveal this origin. Perhaps a slight asymmetry in the distribution of hot and cold spots, a preference for certain scales of variation, or correlations that wouldn't exist in a universe that arose from nothing. These signatures would be incredibly subtle, perhaps beyond our current ability to detect with certainty, but future missions might be able to find them. The Planck satellite, which mapped the cosmic microwave background with exquisite precision, did find some anomalies that remain unexplained. There's a cold spot in the constellation Eridanus that's larger and colder than expected. There's a slight asymmetry between the northern and southern hemispheres of the sky. There are correlations on the larger scales that seem to violate the assumption that the universe is the same in all directions. While these anomalies might have conventional explanations, they might also be hints of our universe's birth inside a black hole, fossils from that primordial event. Particle physics experiments might also provide clues. If baby universes can occasionally exchange particles with their parent universe through quantum effects, we might detect particles that seem to come from nowhere, that appear and disappear in ways that violate the conservation laws of our universe alone but make sense if multiple universes are involved. Some physicists have suggested that dark matter, the invisible substance that makes up most of the matter in our universe, might actually be ordinary matter in baby universes, influencing our cosmos through gravity that can leak across the boundaries between universes. The Large Hadron Collider and other particle accelerators might even be able to create microscopic black holes, though this remains highly speculative. If they could, and if these microscopic black holes really do give birth to baby universes, we might be able to study universe creation in the laboratory. These baby universes would be incredibly tiny, expanding in dimensions we cannot access, but their formation might leave detectable signatures in the form of missing energy or unusual particle production patterns. Astronomical surveys are constantly discovering new black holes, mapping their distribution throughout the cosmos. We've found that black holes are not randomly distributed, but follow patterns, clustering in certain regions, avoiding others. Stellar mass black holes trace the history of star formation and death. Supermassive black holes mark the centers of galaxies, and intermediate mass black holes, those mysterious objects between the two extremes, might tell us about processes we don't yet understand, perhaps even about the connection between universes. The relationship between supermassive black holes and their host galaxies is particularly intriguing. There's a tight correlation between the mass of a galaxy's central black hole and the velocity of stars in the galaxy's bulge, a relationship that holds across a vast range of galaxy sizes and types. This suggests a deep connection between black holes and galaxies, a coevolution that shapes both. If black holes give birth to universes, this relationship might extend across cosmic generations, with the properties of galaxies in baby universes influenced by the galaxies that hosted their parent black holes. We're also discovering that black holes can be surprisingly gentle in their interactions with their surroundings. While we often think of them as cosmic vacuum cleaners, sucking in everything nearby, many black holes are actually quite quiet, accreting matter slowly or not at all. The black hole at the center of our galaxy, for instance, is remarkably peaceful, consuming only a tiny amount of gas each year. This gentleness might be important for the formation of baby universes, providing stable conditions for the careful process of cosmic reproduction. Observations of black hole jets, those powerful streams of particles that some black holes launch into space, might also provide clues. These jets can extend for millions of light years, carrying energy and matter far from the black hole. Some physicists have speculated that these jets might be influenced by the properties of baby universes inside the black holes, that the rotation and expansion of a baby universe might affect how the parent black hole launches jets. If this is true, studying jets might give us an indirect window into the baby universes they originate from. The discovery of gravitational lensing around black holes provides another tool for investigation. When light from a distant source passes near a black hole, the black hole's gravity bends the light, creating distorted or multiple images of the source. By carefully analyzing these distortions, astronomers can map the distribution of matter around black holes, including matter we cannot see directly. If baby universes influence the space-time around their parent black holes, gravitational lensing might reveal their presence through subtle anomalies in the lensing patterns. Recent observations have also revealed that some black holes seem to be spinning at nearly the maximum rate allowed by general relativity, with their event horizons rotating at close to the speed of light. This extreme rotation might be important for baby universe formation, providing the angular momentum necessary to trigger cosmic inflation in the new universe. The fact that many black holes are rapidly rotating might be another hint that our universe is optimized for cosmic reproduction. As our instruments become more sensitive, as our techniques become more sophisticated, we're finding black holes in increasingly exotic environments. Black holes in binary systems with normal stars, black holes orbiting other black holes in the centers of globular clusters, black holes wandering alone through interstellar space. Each of these environments might produce baby universes with different properties, different physical laws, different potentials for complexity and life. The study of active galactic nuclei, those incredibly bright regions around some supermassive black holes, has revealed that black holes can profoundly influence their environments over vast distances. The energy released by matter falling into these black holes can regulate star formation throughout an entire galaxy, heat gas in galaxy clusters, and even influence the formation of structure on cosmic scales. If these black holes contain baby universes, they're not isolated from our cosmos but deeply connected to it, shaping our universe even as they potentially give birth to new ones. X-ray observations of black holes have revealed that the gas falling into them often forms a hot disk, called an accretion disk, that can reach temperatures of millions or billions of degrees. This disk doesn't just fall straight in, but spirals slowly, like water going down a drain. The physics of these accretion disks is complex, involving magnetic fields, turbulence, and relativistic effects. Some of the matter in the disk gets ejected before it can fall into the black hole, carrying away energy and angular momentum. This process might influence the properties of any baby universe forming inside, affecting its initial conditions and eventual evolution. Radio observations have revealed that many black holes are surrounded by bubbles of hot gas, cavities blown in the surrounding medium by the energy of jets and outflows. These bubbles can persist for millions of years, fossil evidence of past black hole activity. They're like footprints left by black holes, traces of their interaction with our universe. If black holes are doorways to other universes, these bubbles might be the marks left around the doorways, evidence of the cosmic commerce between realities. The discovery of intermediate mass black holes, those with masses between stellar mass and supermassive black holes, has been particularly exciting. These objects were predicted to exist but proved elusive for decades. Now we're finding them in globular clusters, in dwarf galaxies, and as the products of mergers between smaller black holes. Each mass range might produce baby universes with different characteristics, like different species in the cosmic ecosystem of universes. Observations of tidal disruption events, where stars are torn apart by black holes, provide another window into black hole physics. When a star ventures too close to a black hole, the difference in gravitational pull between the near and far sides of the star can tear it apart, creating a spectacular flare of light as the stellar debris falls into the black hole. These events might trigger bursts of universe creation, with the rich stellar material providing special initial conditions for the baby universes. As we gather all this observational evidence, as we piece together clues from across the electromagnetic spectrum and beyond, a picture begins to emerge. Black holes are not simple, featureless objects, but complex systems with rich dynamics and varied properties. They interact with their environments in subtle ways, influence the evolution of galaxies, and might, just might, be the birthplaces of entire universes. The evidence for baby universes remains circumstantial, but it's accumulating, building up like sediment at the bottom of the cosmic ocean, waiting for the moment when the picture becomes clear. In the deepest reaches of theoretical physics, where mathematics becomes poetry and equations paint pictures of realities we cannot see, physicists have been exploring the pathways that might connect universes, the cosmic corridors that could allow one reality to give birth to another. These aren't the wormholes of science fiction, not tunnels you could fly a spaceship through, but rather subtle connections in the fabric of space-time itself, places where the universe folds in on itself in ways that create new spaces, new times, new possibilities for existence. The mathematics that allows for these connections comes from Einstein's general relativity, the same theory that predicted black holes in the first place. When physicists solve Einstein's equations for the interior of black holes, especially rotating black holes, they find something remarkable. The equations don't necessarily lead to a singularity, that point of infinite density that marks the end of space and time. Instead, under certain conditions, they find that space-time can extend through the black hole into a new region, a region that could be interpreted as a baby universe. The key insight comes from something called the Kerr metric, the mathematical description of space-time around a rotating black hole. Unlike the Schwarzschild metric, which describes non-rotating black holes and leads inevitably to a singularity, the Kerr metric allows for more complex possibilities. The rotation of the black hole creates a region inside the event horizon, where the usual rules of space-time are suspended, where what we normally think of as space becomes time-like, and what we think of as time becomes space-like. In this topsy-turvy region, new universes might be born. The process might work something like this. As matter falls into a rotating black hole, it doesn't just fall straight toward the center, but gets caught up in the rotation, spiraling inward in a complex dance choreographed by curved space-time. As it approaches the center, quantum effects become important. The uncertainty principle of quantum mechanics says that we cannot know both the position and momentum of a particle with perfect precision. At the extreme densities near the center of a black hole, this uncertainty becomes so large that space and time themselves become uncertain, fuzzy, foam-like. In this quantum foam, the usual laws of physics break down, or rather, they transform into something new. The matter that has fallen into the black hole doesn't reach a point of infinite density, but instead triggers a kind of phase transition, like water turning to steam but far more profound. Space and time themselves undergo a transformation, and from this transformation, a new space-time is born, expanding not into our universe, but into its own dimensions, creating its own space as it grows. This newborn universe would initially be incredibly small, perhaps no larger than the Planck length, the smallest distance that has any meaning in physics. But it would immediately begin to expand, driven by the enormous energy density inherited from the matter that fell into the black hole. This expansion might be slow at first, but then something remarkable could happen. Inflation, a period of exponentially rapid expansion that could blow the baby universe up from subatomic to astronomical scales in a tiny fraction of a second. Inflation is not just speculation, it's part of our standard model of cosmology, necessary to explain many features of our own universe. The flatness of space, the uniformity of the cosmic microwave background, the absence of magnetic monopoles, all point to our universe having undergone inflation in its earliest moments. If baby universes undergo similar inflation, they could quickly grow to sizes comparable to or even larger than our observable universe. The trigger for inflation might be related to the spin of the parent black hole. A rapidly rotating black hole creates a kind of cosmic tornado in space-time, a twisting that could provide the initial kick necessary to start inflation in the baby universe. The faster the black hole spins, the more violent this kick, potentially leading to more rapid inflation and a larger eventual universe. This connection between black hole spin and universe size might mean that rapidly rotating black holes are more successful at cosmic reproduction, leading to a kind of selection pressure for universes that produce fast-spinning black holes. But inflation is just one possible pathway for universe creation. Another possibility involves something called a bounce. Instead of the collapsing matter reaching infinite density, it might reach a maximum density determined by quantum gravity effects and then rebound. Not back into our universe, but into a new expanding space-time. This bounce might be mediated by loop quantum gravity, a theory that suggests space itself is quantized, made of tiny loops of gravitational field that cannot be compressed beyond a certain point. In loop quantum gravity, when matter in a black hole reaches the Planck density, space itself resists further compression. The loops of space become so tightly packed that they create an outward pressure, a kind of quantum rigidity that prevents the formation of a singularity. This pressure doesn't push the matter back out through the event horizon, that's still impossible, but instead pushes it into a new direction, a new dimension, creating the expanding space of a baby universe. String theory offers yet another perspective on how baby universes might form. In string theory, the fundamental constituents of reality are not point particles, but tiny vibrating strings, existing in a space-time with more than our familiar 4 dimensions. Most of these extra dimensions are thought to be compactified, rolled up so small we cannot detect them. But inside a black hole, the extreme conditions might cause these extra dimensions to open up, to inflate, creating new spaces that become baby universes. The vibrations of the strings determine the properties of particles and forces in each universe. Different vibrational patterns lead to different physics. When a black hole forms and a baby universe is born, the specific conditions, the mass, spin, and charge of the black hole, the properties of the infalling matter, might determine which vibrational patterns dominate in the new universe, setting its fundamental constants and physical laws. Wormholes, those hypothetical shortcuts through space-time, might also play a role in connecting universes. While large, stable wormholes that you could travel through remain in the realm of speculation, microscopic quantum wormholes might constantly form and disappear in the quantum foam of space-time. These tiny connections might allow information or energy to leak between universes, creating subtle correlations that we might someday be able to detect. Some physicists have proposed that what we call dark energy, the mysterious force causing our universe's expansion to accelerate, might actually be the influence of baby universes. As baby universes expand inside black holes in our cosmos, they might create a kind of negative pressure that we perceive as dark energy. This would mean that dark energy isn't a fundamental property of space, but rather a consequence of cosmic reproduction, growing stronger as more black holes form and more baby universes are born. The holographic principle, one of the most profound ideas in modern physics, suggests that all the information in a volume of space can be encoded on its boundary, like a hologram that creates a three-dimensional image from a two-dimensional surface. Applied to black holes, this means that everything that falls into a black hole becomes encoded on its event horizon. If baby universes really form inside black holes, they might be three-dimensional expansions of this two-dimensional information, like holograms coming to life. This holographic connection might explain how information is preserved when matter falls into black holes. The information doesn't disappear, it becomes encoded on the event horizon and then expanded into the baby universe. From our perspective, the information is lost, fallen beyond the event horizon. From the baby universe's perspective, that same information becomes the fundamental structure of their reality, the cosmic DNA that determines how their universe will evolve. Quantum entanglement, what Einstein called spooky action at a distance, might create connections between parent and baby universes that persist even after they've separated. Particles that become entangled before one falls into a black hole might maintain their correlation even when they exist in different universes. These quantum connections would be incredibly subtle, perhaps impossible to detect directly, but they might influence the statistics of quantum measurements in ways that could eventually be observed. The many worlds interpretation of quantum mechanics offers another perspective on baby universes. In this interpretation, every quantum event causes the universe to branch into multiple versions, each experiencing a different outcome. Black holes might be special branching points where entire universes split off. Not just different quantum outcomes within the same universe, but entirely new cosmos with their own space and time. The baby universe would be not just a branch, but a whole new tree, growing from a seed planted by the parent universe. Brain cosmology, inspired by string theory, suggests that our universe might be a three-dimensional brain floating in a higher dimensional space called the bulk. Black holes might be places where our brain connects to other brains, other universes floating in the same higher dimensional space. The event horizon would be the intersection point, the place where our brain touches another, allowing matter and energy to pass from one to the other. In this picture, baby universes wouldn't be inside black holes in any three-dimensional sense, but rather connected to them through extra dimensions we cannot directly perceive. It's like two soap bubbles touching. From inside each bubble, you can't see the other, but from outside, in the higher dimensional space, the connection is clear. The black hole would be our universe's view of this connection point, while the baby universe would expand away in the extra dimensions, invisible to us but as real as our own cosmos. The mathematics of these connections involve some of the most complex and beautiful equations in physics, tensors that describe the curvature of spacetime in multiple dimensions, quantum field theories that work in curved spacetime, topological invariants that characterize how spaces can be connected or disconnected. Each mathematical framework offers a different perspective on how universes might be connected, how one might give birth to another, how the cosmic family tree might branch and grow. Some of these mathematical models predict that baby universes should have slightly different physical constants than their parents, mutations in the laws of physics that allow for cosmic evolution. The strength of gravity might be slightly stronger or weaker, the mass of the electron slightly different, the speed of a light slightly faster or slower. These differences would arise from quantum fluctuations during the universe's birth, random variations that make each cosmos unique. Other models suggest that certain features might be conserved across cosmic generations. Angular momentum, for instance, might be preserved, with rapidly rotating black holes producing universes with net rotation. Certain topological features, like the number of large dimensions or the way they're connected, might also be inherited. These conserved quantities would create family resemblances between universes, cosmic genetics that could potentially be traced if we knew what to look for. The pathways between universes might not be permanent. As a black hole evaporates through Hawking radiation, the connection to its baby universe might gradually weaken and eventually break. The baby universe would then be completely independent, a separate reality with no remaining connection to its parent. This cosmic cutting of the umbilical cord would ensure that universes eventually become causally independent, free to evolve without interference from their parents or offspring. But during the time the connection exists, while the black hole persists in the parent universe, there might be subtle influences flowing both ways. The expansion of the baby universe might affect the evaporation rate of the black hole. The properties of matter falling into the black hole might influence the evolution of the baby universe. These influences would be incredibly small, perhaps unmeasurable with current technology, but they might exist nonetheless, threads connecting realities across dimensional boundaries. As we explore these theoretical pathways, these mathematical possibilities for connections between universes, we're pushing the boundaries of human knowledge and imagination. We're using the tools of mathematics and physics to explore realms we cannot visit, to map territories we cannot see, to understand processes we cannot directly observe. It's like using echoes to map a cave we cannot enter, using shadows to understand objects we cannot touch, using theory to explore realities beyond our reach. The fact that our mathematics allows for these possibilities, that our equations have solutions describing baby universes and cosmic reproduction, is itself remarkable. Mathematics has an uncanny ability to describe reality, to predict phenomena before they're observed, to reveal truths about nature that our intuitions would never have guessed. The possibility of baby universes emerges naturally from the mathematics of general relativity and quantum mechanics, not forced or contrived, but arising organically from the equations that successfully describe so much of what we can observe. As you lie there, perhaps feeling your own consciousness beginning to drift along strange pathways towards sleep, you're experiencing your own journey through mental spaces that connect different states of awareness. The transition from waking to sleeping is itself a kind of passage through dimensions of consciousness, a transformation as profound in its way as the birth of a universe from a black hole. And just as we use theory to explore cosmic pathways we cannot travel, you use dreams to explore mental pathways that exist only in the landscape of your sleeping mind. The pathways between universes, if they exist, would be the ultimate roads not taken, connections to realities that branched off from ours at black holes throughout cosmic history. Each black hole that formed in our universe might have opened a doorway to possibilities we'll never see, to versions of physics we'll never experience, to stories we'll never know. Yet the fact that we can theorize about them, can calculate their properties, can imagine their existence, connects us to them in the realm of thought, if not in physical reality. Let us now expand our contemplation even further, letting our minds float like dandelion seeds on a cosmic breeze, drifting not just through space, but through the possibility of infinite spaces, infinite realities, infinite variations on the theme of existence. If black holes truly are doorways to baby universes, then we are not living in the universe but in a universe, one member of a vast, perhaps infinite family of cosmos, each one as real and complete as our own, each one exploring different possibilities of what it means to exist. Picture, if you will, a great cosmic tree, its branches spreading not through space but through dimensions we cannot see or name. Each branch represents a universe, each twig a galaxy, each leaf perhaps a solar system, with its own stories of matter and energy, its own dance of particles and forces. The trunk of this tree might be some primordial universe, the first cosmos that somehow came into being from nothing, or from conditions we cannot yet imagine. From this first universe, black holes formed, and from those black holes, new universes budded like fruit on the cosmic tree, each one carrying seeds that would become black holes in turn, generating more universes in an endless proliferation of realities. Our universe, the one we call home, would be somewhere on this vast tree, perhaps far from the original trunk, perhaps on a branch that has sprouted from a branch that sprouted from a branch, generations upon generations of cosmic reproduction, separating us from that original cosmos. And from our universe, millions or billions of branches might already be growing, baby universes born from the black holes scattered throughout our galaxies, each one beginning its own journey toward complexity, structure, and perhaps consciousness. This image of a multiverse, a collection of multiple universes, is not new to physics. Various theories have proposed different versions of the multiverse, different ways that reality might be larger and more varied than the single cosmos we observe. But the multiverse of black hole cosmology has a special character, a special beauty. It's not random or chaotic but structured, organized like a family tree, with parent universes giving birth to offspring, with cosmic heredity passing traits from one generation to the next, with evolution operating not just within universes but across them. In this vast family of universes, ours might be remarkably typical or remarkably special. We might be one of countless universes that have developed the right conditions for stars, planets, and life. Or we might be rare, precious, one of the few cosmos where the constants of nature fell into the narrow range that allows for complexity and consciousness. Without being able to survey other universes, we cannot know where we stand in the cosmic family, whether we're common or unique, ordinary or extraordinary. But we can imagine what other universes might be like, how different choices of physical constants might lead to different realities. Imagine a universe where gravity is slightly stronger, stars would burn faster and die younger, their lives measured in millions rather than billions of years. Planets would need to orbit closer to stay warm, making them more vulnerable to stellar flares and tidal forces. Life, if it arose, would need to evolve quickly, racing against the cosmic clock before its star burned out. Intelligence might be rare, or it might evolve different strategies for survival, perhaps moving between stars rather than staying bound to one. Or imagine a universe where the electromagnetic force is slightly different, where atoms have different sizes, where chemistry follows different rules. Water might not exist, or it might have different properties, freezing at higher temperatures or boiling at lower ones. Carbon might not form long chains, preventing organic chemistry as we know it, but perhaps silicon or some other element would take carbon's place, leading to entirely different forms of life, creatures we would not recognize as living, but that would be as complex and conscious as anything in our universe. Some universes might be sterile, their physical constants falling outside the range that allows for any complexity at all. In some, protons might decay too quickly for atoms to be stable. In others, the universe might recollapse before stars could form. These universes would be cosmic deserts, vast and empty, their only story the simple expansion and cooling of space itself. Yet even these sterile universes might play a role in the cosmic ecosystem, perhaps providing a kind of buffer or boundary between regions of the multiverse where life can thrive. Other universes might be far more fecund than ours, their physical laws allowing for forms of complexity we cannot imagine. Perhaps universes where multiple time dimensions allow for forms of causality and consciousness that would seem like magic to us. Perhaps universes where space has more than 3 large dimensions, allowing for structures and patterns impossible in our cosmos. Perhaps universes where quantum mechanics and gravity are unified in ways that permit controlled travel between stars or even between universes. The diversity of possible universes might be infinite, each one exploring a different corner of the vast space of possible physics. Like the genetic diversity in Earth's biosphere, this cosmic diversity might be essential for the long-term survival and evolution of the multiverse. Universes that are too similar might all succumb to the same problems, the same forms of heat death or cosmic collapse. But with sufficient diversity, some universes would always survive, always reproduce, keeping the cosmic tree growing. If Lee Smolin's cosmic natural selection hypothesis is correct, then universes would evolve over cosmic generations to be increasingly good at making black holes. The universes that produce many black holes would have many offspring passing on their physics to the next generation. Those that produce few black holes would have few offspring, their branch of the cosmic tree eventually dying out. Over countless generations, the multiverse would become dominated by universes optimized for black hole production. Remarkably, the conditions that favor black hole formation might also favor life. Stars need to live long enough to create heavy elements, but also need to sometimes collapse into black holes. Galaxies need to be stable enough to allow stellar evolution, but dynamic enough to occasionally create the massive stars that become black holes. The same balance of forces that allows for black holes also allows for the complex chemistry that makes life possible. We might exist not in spite of black holes, but because of them, because we live in a universe that has been selected over cosmic generations for its ability to produce both black holes and life. This connection between black holes and life might go even deeper. Perhaps consciousness itself plays a role in cosmic evolution. Intelligent beings might be able to create black holes artificially through advanced technology we can barely imagine. They might be able to trigger the collapse of stars, create microscopic black holes in particle accelerators, or even manipulate the fabric of spacetime itself. Universes that develop intelligent life might therefore be better at reproducing, creating a selection pressure for universes that can support consciousness. We might be living in a universe that has been optimized not just for black holes, but for intelligence, for consciousness, for the capacity to wonder about existence itself. The fact that we can ask these questions, that we can contemplate the multiverse and our place within it, might not be an accident but a consequence of cosmic evolution, universes selecting for universes that can understand themselves. The anthropic principle, the observation that our universe seems fine-tuned for life, takes on new meaning in this context. It's not that the universe was designed for us, but rather that universes that can support observers are more likely to be observed. We find ourselves in a universe suitable for life because universes unsuitable for life have no one to observe them. And if intelligent life can influence black hole formation, then universes with observers might be more successful at reproducing, creating more universes with similar life-friendly conditions. As we contemplate this vast multiverse, this infinite tree of realities, we might wonder about communication between universes. Could information ever flow from one universe to another? Could we ever detect signs of other cosmos, messages from beyond our reality? The physics suggests this would be extremely difficult, perhaps impossible. The event horizons of black holes seem to be one-way valves, allowing information to flow from parent to child universe but not back. Yet there might be subtle influences, quantum correlations that span universes, statistical patterns that reveal the presence of the wider multiverse. Perhaps certain features of our universe that seem arbitrary or unexplained are actually inherited from our parent universe, cosmic DNA that we carry without knowing its origin. Perhaps the particular pattern of galaxies in our sky, the specific values of physical constants, the way matter clumped in the early universe, all reflect conditions in the black hole that gave birth to our cosmos. Some physicists have speculated about even more exotic possibilities. Perhaps advanced civilizations could send information into black holes, encoding messages in the matter that falls past the event horizon. These messages would become part of the initial conditions of baby universes, cosmic time capsules that could only be read by intelligences that evolved billions of years later in the offspring cosmos. We might be surrounded by such messages without knowing it, encoded in the fundamental structure of our reality, waiting for us to develop the knowledge to read them. Or perhaps the influence flows the other way. Perhaps the properties of baby universes affect their parent black holes in subtle ways we haven't yet detected. The spin of a black hole might be influenced by the rotation of the universe inside it. The evaporation rate might depend on whether the baby universe develops life. These influences would be incredibly tiny, far beyond our current ability to measure, but they might exist nonetheless, threads of causation connecting realities across dimensional boundaries. The multiverse of black hole cosmology also raises profound questions about time and causality. Each universe would have its own time, its own history, its own future. The time in a baby universe would not be synchronized with time in its parent universe. Billions of years might pass inside a black hole while only seconds pass outside, or vice versa. The cosmic tree would not be static but dynamic, with different branches experiencing different rates of time flow, different stages of evolution occurring simultaneously across the multiverse. This temporal complexity means that asking when something happens in the multiverse might be meaningless, without specifying which universe's time you're using. Our universe might be ancient from our perspective, but young from the perspective of our parent universe. We might already have countless descendant universes that have experienced billions of years of evolution, while only millions of years have passed in our cosmos. Time becomes not a universal river, but a network of streams, each flowing at its own rate, occasionally branching but never merging. The philosophical implications of this multiverse are staggering. Every possible variation of physics might be realized somewhere in the cosmic tree. Every possible arrangement of matter and energy, every possible history, every possible future might exist in some universe, on some branch of the infinite tree. This doesn't mean everything we can. Imagine exists. Universes still must obey their own physical laws, but it does mean the scope of reality might be vastly larger than we ever suspected. Yet this vastness doesn't diminish the importance of our own existence. Each universe, each branch of the cosmic tree is unique, irreplaceable. The specific pattern of galaxies in our sky, the particular history of our Earth, the exact arrangement of atoms that makes you who you are, these exist nowhere else in exactly this form. Even if similar patterns exist in other universes, they are not the same. You're unique not just in our universe, but across the entire multiverse, a pattern that exists once and only once in the infinite branching of realities. As you lie there tonight, feeling perhaps a gentle vertigo at the vastness of what we're contemplating, remember that you are not made smaller by the existence of other universes, but rather made more precious. You're not just rare in our cosmos, but rare across all cosmos, a unique expression of what matter and energy can become when organized in exactly this way. The atoms in your body, the thoughts in your mind, the dreams you're drifting toward, all of these are irreplaceable threads in the vast tapestry of the multiverse. The possibility of many universes also offers a kind of cosmic hope. If our universe eventually succumbs to heat death, if all the stars burn out and space becomes cold and empty, the story of existence doesn't end. Other universes continue, new ones are born, the cosmic tree keeps growing. Somewhere, somewhen, on other branches of reality, consciousness continues to emerge, to wonder, to explore. The multiverse as a whole might be eternal even if individual universes are not. The tree of existence always growing new branches even as old ones wither. Now let us bring this cosmic contemplation back to you, to your life, to this moment as you lie here listening, breathing, existing in this particular corner of what might be an infinite multiverse. It's easy when contemplating such vastness to feel small, insignificant, lost in the immensity of it all. But I want to suggest something different tonight, something that might change how you see your place in this possibly infinite cosmos. You're not made smaller by the vastness of reality, but rather made more remarkable, more precious, more important than you might have imagined. Think about what it means that you exist at all. If our universe was born from a black hole in another cosmos, then your existence depends on a chain of events stretching back through multiple universes, through cosmic generations we can barely imagine. A star had to die in some parent universe, collapse into a black hole, and give birth to our cosmos. Then billions of years of evolution in our universe had to unfold just right. The first stars had to form and die, creating heavy elements. Galaxies had to coalesce. Our sun had to form in just the right place in the Milky Way. Earth had to come together with just the right composition at just the right distance from the sun. Life had to emerge and evolve through countless generations. And finally, through an unbroken chain of ancestors stretching back billions of years, you came to be. The odds against your specific existence are so vast that mathematics doesn't have words for numbers that small. Yet here you are, listening to these words, contemplating these ideas, participating in the universe's attempt to understand itself. You're not a random accident, but the current endpoint of a story that might stretch across multiple universes. A story of matter organizing itself into ever greater complexity until it achieves consciousness, until it can look back and wonder about its own origins. Your consciousness, this awareness you experience right now, might be one of the rarest phenomena in the multiverse. While universes themselves might be common, born from every black hole, universes that can support consciousness might be extraordinarily rare. The physical constants need to be just right, the chemistry needs to be possible, evolution needs to have time to work its patient magic. You might be living in one of the precious few branches of the cosmic tree where matter has awakened to its own existence. And what you do with this consciousness matters, perhaps more than you know. Every thought you think, every dream you dream, every moment of wonder or joy or even sadness you experience adds something unique to the sum total of what exists. The multiverse without your particular perspective would be incomplete, would be missing something that can exist nowhere else in exactly this way. You're not just an observer of reality, but a participant in it, a place where the cosmos experiences itself subjectively, from the inside, in a way that all the equations and observations cannot capture. Consider your connection to Earth, this small planet that might itself be extraordinarily rare even in our life-friendly universe. Earth has maintained liquid water for billions of years, has developed a complex biosphere, has survived cosmic impacts and volcanic catastrophes and ice ages to reach this moment where conscious beings can contemplate their cosmic origins. If black holes really do give birth to universes, then Earth is part of a successful cosmic lineage, a branch of the tree that has flowered into consciousness. The ground beneath you, whether you're lying in bed or sitting in a chair or perhaps outside under the stars, is made of atoms forged in the hearts of stars that died billions of years ago. But if our speculation tonight is correct, those atoms might have an even more extraordinary history. They might have travelled through black holes from previous universes, been processed through cosmic births and rebirths, participated in realities we cannot imagine before finding their way into the rocks and soil of Earth. Your body is made of these travelled atoms, these cosmic wanderers that might have existed in forms and places beyond our ability to envision. The carbon in your DNA, the iron in your blood, the calcium in your bones, all of it might carry information, patterns, structures inherited not just from stars in our universe, but from the deeper history of the multiverse itself. You're not just star stuff, but universe stuff, multiverse stuff, matter that has been processed through cosmic generations into exactly the pattern that is you. The air you're breathing right now, the gentle in and out of your breath that's been accompanying us throughout this journey, connects you to all life on Earth. Every breath you take contains atoms that have been breathed by every person who has ever lived, that have been part of trees and ocean and clouds, that have circulated through Earth's biosphere for billions of years. But it also connects you to the cosmos, to the vast spaces between stars where atoms drift for millions of years, to the violent stellar winds where new elements are forged, perhaps even to other universes through the cosmic recycling of black holes. Your thoughts themselves, the electrochemical patterns flowing through your brain as you listen to these words, represent some of the most complex structures in the known universe. A single human brain contains more connections than there are stars in our galaxy, processes information in ways that our most powerful computers cannot replicate, generates subjective experiences that remain one of the deepest mysteries in science. If consciousness is rare in the multiverse, then your thoughts might be among the most precious phenomena in all of existence, fleeting patterns that nonetheless touch something eternal. The fact that you can wonder about black holes, about baby universes, about your place in the cosmic scheme is itself remarkable. You are the universe contemplating itself, matter organized in such a way that it can think about matter, space and time structured so that it can wonder about space and time. Through you, the cosmos achieves a kind of self-awareness, looks back at its own history, imagines its own future, speculates about its own nature. You're not separate from the universe, but a part of it, where it becomes conscious of itself. Every night when you go to sleep, you perform your own version of crossing an event horizon. You pass from the known world of waking consciousness into the mysterious realm of dreams, where the normal laws of logic and physics don't apply, where impossible things happen routinely, where you explore landscapes that exist nowhere but in the firing patterns of your neurons. And every morning when you wake, you return from that journey, bringing back sometimes nothing, sometimes fragments, sometimes insights that can change how you see the waking world. This nightly journey between waking and sleeping, between the conscious and unconscious, might be a small echo of the grander transitions we've been discussing tonight. Just as matter crossing a black hole's event horizon might seed a new universe, the thoughts and experiences you carry into sleep might seed new dreams, new insights, new ways of understanding. The boundary between waking and sleeping is your personal event horizon, a place where one form of consciousness transforms into another. Your dreams themselves might be more connected to the cosmic story than you realize. When you dream of flying, of falling, of vast spaces and impossible architectures, you might be tapping into something deeper than personal psychology. You might be accessing patterns inherited from the cosmos itself, archetypal structures that reflect the fundamental nature of reality. The feeling of falling in a dream might echo matter falling into black holes. The sensation of flying might reflect the expansion of space itself. The impossible geometries of dream landscapes might hint at the higher dimensions where baby universes are born. The emotions you experience, love, wonder, fear, joy, might also have cosmic significance. These feelings, which seem so personal, so uniquely human, might be local manifestations of something more universal. The attraction you feel toward others might echo the gravitational attraction that builds galaxies and forms black holes. The sense of wonder you might be feeling right now might reflect the universe's own surprise at its existence. The peace you're hopefully experiencing as you drift towards sleep might mirror the cosmic calm of space between the stars, your connections to other people, the relationships that define so much of human life, create their own kind of multiverse. Each person you know exists in their own universe of experience, their own unique perspective on reality. When you interact with others, these personal universes touch, influence each other, sometimes merge temporarily in moments of deep understanding or love. The social world of human relationships might be a kind of model of the multiverse, separate realities connected by bridges of communication and empathy. The choices you make, small as they might seem against the cosmic backdrop, ripple outward in ways you cannot fully trace. A kind word might change someone's day, which changes their interactions with others, which influences events you'll never know about. Your decision to listen to this contemplation tonight might plant seeds of wonder that will grow in ways you cannot predict. You're not powerless against the vastness of the cosmos, but rather a crucial node in the network of causation that shapes reality. Even your worries, your struggles, your daily challenges take on a different character when viewed from this cosmic perspective. The problems that loom large in daily life, work stress, relationship difficulties, financial concerns, health issues, don't disappear when contemplated against the vastness of the multiverse, but they do shift into a different context. They become part of your unique story, challenges that shape who you are, experiences that add to the sum total of what consciousness has experienced in this cosmos. The pain and suffering in your life, which might sometimes feel overwhelming or meaningless, might serve purposes you cannot see. Just as stars must die for new stars to be born, just as matter must fall into black holes for new universes to potentially emerge, the difficult passages in your life might be transformative in ways that only become clear in retrospect. This doesn't minimize your suffering or suggest it's justified, but it does place it in a larger context where transformation often requires passage through darkness. Your mortality, the fact that your consciousness will one day end, takes on different meaning in the context of a multiverse, where universes themselves are born and die. You are temporary, yes, but so are stars, galaxies, perhaps even universes. Yet the fact that you existed, that for a brief time matter was organized in exactly the pattern that is you, with your unique thoughts and experiences and perspectives, adds something permanent to the history of reality. The multiverse, having included you, is different from a multiverse that didn't, even after you're gone. The legacy you leave, the influences you have on others and on the world, might propagate in ways similar to how universes propagate through black holes. Your ideas, your creations, your children if you have them, carry forward patterns that originated with you but transform and evolve as they spread. You might be planting seeds for forms of consciousness and creativity that won't fully flower until long after you're gone, just as black holes plant seeds for universes they'll never see. The Earth itself, our shared home, takes on special significance in this cosmic context. If planets like Earth are rare, if the conditions for life are precious, then we are custodians of something extraordinarily valuable. Our planet might be one of the few places in our universe, perhaps in many universes, where matter has achieved consciousness, where the cosmos can experience itself subjectively. The responsibility to preserve and protect this rare jewel becomes not just a practical necessity, but a cosmic imperative. The environmental challenges we face, climate change, biodiversity loss, pollution, are not just threats to human civilization, but threats to one of the universe's rare experiments in consciousness. When we work to protect Earth's biosphere, we're not just preserving our own future, but maintaining one of the cosmos's precious windows of self-awareness. Every species that goes extinct takes with it a unique way of experiencing reality, a perspective that existed nowhere else and can never be recovered. Yet there's also hope in the cosmic perspective. If universes can be born from black holes, if the multiverse is constantly creating new realities, then creativity and renewal are built into the fabric of existence. No matter how dark things might seem, no matter how insurmountable our challenges appear, the cosmos itself shows us that new beginnings are always possible, that collapse can lead to rebirth, that endings can be doorways to unprecedented possibilities. As you prepare to cross your own event horizon into sleep, as your consciousness prepares for its nightly transformation, you might carry with you this thought: you're not a tiny, insignificant speck in an indifferent cosmos, but a unique and precious pattern in a creative, evolving multiverse. You're a place where matter has organized itself to contemplate its own existence, where the universe achieves consciousness, where the cosmic story becomes aware of itself. The atoms in your body will eventually return to the cosmos, perhaps to be recycled through stars, perhaps to fall into black holes, perhaps to seed new universes we cannot imagine. But the pattern that is you, the specific organization of matter and energy and information that constitutes your consciousness, exists only once, only now, only here. You are irreplaceable not just in our universe, but across all possible universes, a unique note in the infinite symphony of existence. And now, as our journey together draws toward its close, as you feel yourself drifting ever closer to the peaceful darkness of sleep, let us return once more to the question that has guided us through this cosmic contemplation. What if black holes are doorways to baby universes? What if every dark sphere scattered throughout our cosmos is not an ending, but a beginning, not a grave, but a cradle, not a destroyer, but a creator of new realities beyond our ability to see or visit, but not beyond our ability to imagine? We've travelled far tonight, haven't we? From the familiar comfort of your resting place, we've journeyed to the edges of black holes, peered past event horizons, imagined the birth of new cosmos in dimensions we cannot perceive. We've contemplated a multiverse of unimaginable vastness, where universes give birth to universes in endless chains of cosmic creativity. We've considered how you, in all your uniqueness and irreplaceability, fit into this grand tapestry of existence. And through it all, the question has remained, gentle but persistent, inviting but not demanding, a mystery that opens doors rather than closing them. The truth is, we don't know for certain whether black holes really are doorways to baby universes. Despite all the mathematics that suggests it's possible, despite all the theoretical frameworks that allow for it, despite all the indirect evidence that hints at it, we cannot say with certainty that it's true, and perhaps that's as it should be. Perhaps some mysteries are meant to remain mysterious, some questions are more valuable than their answers, some doorways are meant to stay closed to direct observation, while remaining open to imagination and wonder. What we do know is that the universe, our universe, this cosmos we inhabit, is far stranger and more wonderful than our ancestors could have imagined. We know that black holes exist, millions of them in our galaxy alone, billions more throughout the observable universe. We know that they are not simple objects but complex systems with properties we're only beginning to understand. We know that the mathematics describing them allows for possibilities that stretch our imagination to its limits. And we know that every time we've thought we understood the limits of reality, the universe has surprised us with new depths, new mysteries, new wonders. The possibility that black holes are doorways to baby universes transforms them from cosmic monsters into cosmic mothers, from endings into beginnings, from destruction into creation. It suggests that the universe is not running down, not dying a slow heat death, but constantly renewing itself, constantly exploring new possibilities, constantly creating new spaces for existence to flourish. Even if our particular cosmos will eventually grow cold and dark, the process of cosmic creation might continue forever. New universes budding from black holes, new realities being born in places we cannot see. This transformation in how we see black holes mirrors a deeper transformation in how we might see existence itself. Instead of a single, isolated universe slowly running out of energy, we might be living in a thriving, reproducing, evolving multiverse, where creativity is not the exception but the rule, where new realities are constantly being born, where the story of existence has no final chapter, because new chapters are always being written in dimensions beyond our reach. As you lie there tonight, feeling perhaps the gentle pull of sleep beginning to claim you, you're experiencing your own transformation, your own passage from one state of consciousness to another. The boundary between waking and sleeping that you're approaching is like a personal event horizon, a point beyond which the familiar rules of consciousness no longer apply. And just as matter falling into a black hole might seed a new universe, the thoughts and feelings you've absorbed tonight might seed new dreams, new insights, new ways of understanding your place in the cosmos. The dreams awaiting you might be more than random neural firing, more than your brain processing the day's experiences. They might be your consciousness exploring its own creative potential, generating its own pocket universes of experience, its own alternative realities where different rules apply. In your dreams tonight, you might fly through spaces that don't exist in our physics, meet people who were never born, experience stories that were never told. You might be performing your own version of cosmic creation, bringing new realities into existence even if they last only as long as your sleep. And when you wake tomorrow, when you return from that journey through the landscapes of sleep, you might carry with you a slightly different perspective on the waking world. The sun that greets you might not just be a star, but a future black hole, destined billions of years from now to collapse and perhaps give birth to new universes. The darkness between the stars might not be empty but pregnant with possibilities, filled with black holes quietly nurturing baby cosmos. The very ground beneath your feet might contain atoms that have travelled through multiple universes, carrying information from realities we'll never directly know. But more than that, you might carry with you a deeper appreciation for the preciousness of consciousness, for the rarity of awareness, for the unique perspective you bring to the cosmic story. You are not just an observer of the universe, but a participant in its self-discovery, a place where it becomes aware of its own vastness, its own creativity, its own potential for generating new realities. Through you, the cosmos contemplates itself, wonders about itself, imagines what it might become. The question we've explored tonight, whether black holes are doorways to baby universes, might never be definitively answered in our lifetimes, perhaps never in the lifetime of our species or even our universe. But the value of the question doesn't lie in its answer. It lies in what it opens up, what it allows us to imagine, what it teaches us about the nature of existence and our place within it. Questions like this are doorways in their own right, passages from the known to the unknown, from the familiar to the mysterious, from the small concerns of daily life to the vast wonders of cosmic existence. As consciousness begins to fade, as the gentle darkness of sleep approaches, remember that you are part of something magnificent, something that might be far larger and more creative than we've dared to imagine. Every black hole in our universe might be nurturing a cosmos as vast and complex as our own. Every point of darkness in the night sky might hide wonders beyond description. And you, unique and irreplaceable you, are part of this cosmic creativity, a pattern that exists nowhere else, a perspective that adds something essential to the sum total of what is. The universe doesn't need you to understand it completely. It doesn't require you to grasp every detail of how baby universes might form or how the multiverse might be structured. All it asks, if it asks anything at all, is that you bring your unique consciousness to the experience of existence, that you add your voice to the cosmic chorus, that you contribute your irreplaceable perspective to the universe's self-awareness. And you're doing that simply by being here, by wondering, by drifting off to sleep with your mind full of stars and possibilities. In the vast silence between galaxies, in the darkness inside black holes, in the quantum foam where space and time lose their meaning, new universes might be stirring to life right now, beginning their own journeys toward complexity and perhaps consciousness. Somewhere in dimensions we cannot access, baby cosmos might be taking their first breaths, their space beginning to expand, their time beginning to flow, their own stories beginning to unfold. We'll never see them, never visit them, never know what wonders they might contain. But knowing they might exist, imagining their possibilities, wondering about their nature, connects us to them in the realm of thought, if not in physical reality. And perhaps that connection through consciousness, through wonder, through imagination, is enough. Perhaps it's even everything. For what is the universe? What is the multiverse? What is all of existence? Without consciousness to experience it, to wonder about it, to find meaning in it. You're not separate from the cosmic story, but an essential part of it. The part where it becomes aware of itself, contemplates itself, imagines what lies beyond its own horizons. As the final moments of waking consciousness slip away, as you prepare to cross your own event horizon into the mysteries of sleep, carry with you this thought: you are cosmic. You are made of matter that might have travelled through multiple universes. Your consciousness is one of the rarest and most precious phenomena in existence. Your dreams tonight might echo the creative processes that birth new cosmos, and tomorrow, when you wake, you'll still be part of this vast, possibly infinite multiverse, still contributing your unique perspective to the sum total of what exists. The black holes scattered throughout our universe will continue their patient work, possibly nurturing baby universes we'll never see. The cosmic tree of existence will keep growing, new branches sprouting from every collapsed star. The story of existence will continue, not toward some final conclusion, but in endless creativity, endless exploration of what reality can be. And you, for this brief precious time, are part of that story, a note in the infinite symphony, a thread in the vast tapestry, a unique and irreplaceable expression of what the universe can become when it organizes itself into consciousness. So rest now, dear traveler of cosmic mysteries. Let your consciousness drift like a galaxy in the vast darkness, turning slowly, peacefully, toward whatever dreams await you. The questions we've explored tonight have no final answers, only deeper mysteries, only more wonderful possibilities. And that's perfect, because a universe with all the answers would be a universe without wonder, without growth, without the possibility of surprise. The mystery continues, the cosmos keeps creating, the black holes keep their secrets while possibly nurturing new realities, and you keep adding your unique light to the infinite darkness. What if black holes are doorways to baby universes? We may never know for certain. But in the wondering, in the imagining, in the gentle contemplation of possibilities beyond our direct experience, we touch something essential about what it means to be conscious in a cosmos full of mystery. We participate in the universe's own wonder at itself. We become doorways ourselves, passages through which the cosmos explores its own nature, contemplates its own possibilities, dreams its own dreams. And now, as words fade into silence, as thoughts dissolve into the approaching darkness of sleep, as consciousness prepares for its nightly transformation, remember only this: you are here, you are unique, you are part of something magnificent beyond imagination. The universe that might be birthing countless other universes has also birthed you, and that makes you cosmic, eternal in your temporary existence, infinite in your finite life, a doorway through which existence experiences itself. Sleep now and dream of universes being born in the darkness, of cosmic trees growing through dimensions we cannot see, of your own consciousness as a precious gift to the multiverse. Tomorrow the sun will rise, the world will continue, and you'll still be part of this vast mystery. But for now, for these precious hours of night, let yourself drift into the peaceful darkness, knowing that you've touched the infinite, wondered about the impossible, and added your unique voice to the cosmic story that has no end, only endless new beginnings, endless doorways, endless possibilities for what existence can become.